Good morning, good afternoon, good evening, everybody. Everybody's doing well. Physics, uh, Robert, Odd Light, welcome on in. It's been an interesting morning. For some reason, the main camera kept freezing. I don't know. Every time I do Microsoft updates, it's almost like I've got to physically unplug and plug my cameras into a different port or they start freezing. It's weird. And then same thing, this monitor, the right side monitor, I've got OBS on, has not flickered, shut off, or anything like that. But left side will like shut down and then come back. It's odd. It's like drivers or something. It's just being stupid. Um, Especially when I'm sitting here trying to look through different manuals to make sure that we can connect things up. Um, so we've been um sorry. So I was looking for some manuals. So today we're going to be working on the tool head for the Trident. Get that going, and then once we get that built to a certain degree, bring the Trident back up here, and we'll start doing install. We have gotten a couple of things in. We did get the. I tried printing. Um, I tried printing some ends. That didn't turn out well at all. So I just ordered some ends. So we'll have some ends to go with our cable change so that we can route the cables from the bed on down. Of course, the tool head's going to be done via a umbilical. And then also on the tool head, we're going to be building the tool head a little bit different. It's going to be what they call the Filametrix tool head or Filametrix. Um, so there's two things. One, it's going to enable us to cut the tip of the filament versus trying to form tips, which could be a lot of the problems or cause a lot of problems. It's one of the things that the Bamboo Lab, you know, X1 and P1 series does well. Filament change. Part of the reason is it just cuts the filament and it makes it a lot easier to, a lot more consistent in loads and unloads filament. The other thing, and I'll show you this. This is, of course, piece of the CW2 here. We have a spot up here for um, an end stop, and we have a spot down here for an end stop. Now, both of these will take I believe it's a 5 or a 5.5 millimeter ball bearing. So you put a ball bearing in, and then it'll be an end stop without a lever. Same thing down here, ball bearing in, and then an end stop with the bumper lined up appropriately. So we're going to have an end stop before the filament gears and then after the filament. This is going to enable the Happy Hair um, firmware to actually auto, we'll say auto correct it. Um, One of the other things that you may notice on this is this piece right here. This is a cutout. Now, the door does not have the matching cutout, right? Doesn't have a matching piece to cover, but I don't care because what this cutout does is it enables um, you to get to the thermistor wire and plug and unplug it without having to take that board off and move it around, which stands a better chance of breaking a wire. So I hope the sound is not going in and out, because the sound, like you hearing me, should be coming through my lav mic, and it sounds like it's pretty good on this end. Now, when we were playing the intro music, I don't know if the desktop audio was dropping out, because once again, my desktop audio is set to go out the left monitor, and every time it would go, the monitor would go blank. Basically, it's losing signal and regrabbing signal. It would drop the audio that I was hearing. Good morning, Pezliz. How are you? Um, so one of the other things I was doing this morning, let me grab the browser one. So, we've got the Trident manual here. We've got the Stealthburner manual. We'll have to flip between the standard Stealthburner manual and the Enraged Rabbit Carrot Feeder GitHub page, because there's really no assembly manual for the Filametrix. So we're going to have to kind of go back and forth a little bit to get that done. But I was also looking over here at the SB2240. So this kit comes with an SB2240. Now I do have some SB2209s, which is what I've used in all of my other Vorons. So we may wind up just using the SB2209 instead of the 2040. The only difference is the driver for the extruder. And I'm not sure what a 2240 buys me over a 22. May just go back and use a standard 20. But the reason I was looking at this schematic is normally I use the end stop plug, which is this, I'll say the top left plug right over here, as the, let me go full display. So normally I'm using this plug right here for the X end stop. Hey, good morning, Two Wolf Design. Thank you for the subscribe. Appreciate that. And then I'm using this 4-pin connector for the whatchamacallit, the CNC tap set. Okay. So this is a 3-pin end stop. This is a 4-pin end stop, and this 4-pin is 5-volt ground and then 2 different pins. So if I could get this to run, if I can get the CNC tap to run 24 volt, which would be great, then I could go right off of the proximity sensor. If not, then I'm going to have to try and figure out how to get the 2 end stops to work, because I need 2 pins and a ground. And I don't know if I can plug the 2 end stops for the Filametrix sensors into the BL Touch section or where. So I'm going to have to figure that out on where I need to plug those two. Okay, Pez. Well, we've got some coffee here, and let me. We've got some coffee in a new cup. Thank you. I believe this was Pete Savis that was had these links out here. So this is my, you know, more than pretty much any vendor. I'm a maker cup. So I was going to get a shirt, and then I decided I'll get coffee cups because, well, we drink coffee here every day. So I guarantee this will get used, where a shirt's going to get thrown in the closet and I may or may not wear it a lot. So, and yes, Mr. Plenty of coffee. Good morning, Creatix Brit. How are you doing? You doing? That squirrel dancing butt is so cute. Love it. Um, yeah, so I finally got this in. I want to say it came in yesterday or maybe even Thursday evening. Um, so freshly washed and freshly got some Dunkin' coffee in it. Yeah. So you'll see we've got all the parts here laid out that we're going to be using today to do our install. Thanks for doing the shout out there, Monlight. If you can do one for Createx Brit as well, I'd appreciate it. So yeah, what one of the things I need to do is just figure out the pin out for the actual in stops and where to do it. So I'm probably going to jump out into Discord and just ask some people like, hey, where are you plugging the end stops in if you're using both end stops? If it was just one end stop, I think I would have the ability to do that fairly easily. But since I'm using both, I just need to make sure of where people are plugging them. Just now, the other thing I was doing was taking a look at the CNC tap, and they've updated the manual. So this manual was updated on the 24th or the 29th of January. And this is good because you've heard me on the last couple of builds make comments about this and the fact that there are different wires and the wires are pinned out different. So if you have the red, black, yellow, it's pinned out correctly in that the red is to the positive, the black is to the ground, and the yellow is the signal. If you've got the red, blue, black, the the black and the blue are reversed, meaning blue is the ground and the black is the signal. Normally you would see black and you would say that's ground. And if you plug those in backwards, you could obviously short or kill your sensor. So I'm glad to see that they made the update in the manual. That was good to see. Good morning, Papa Bear AZ. How are you doing? Yeah, and they made this comment because apparently there was like a whole batch of wires that went out wrong. But they're out there in the wild now, and rather than go and pull all the stock off the shelf and recall everything to swap out a cable, it's easier to tell people, hey, this is where it's at. Um, and what I'm trying to do is just take a quick look here. Wire the signal output from the tap to the servo pin on the probe port of the EBB or motherboard. And that answers my question right here with the preferred method for connection. I have been connecting it up into the end stop on all of my Vorons. What they're saying here is to actually configure it to the servo pins on the EBB. So they're telling you to put it into the BL Touch and starting from, we'll say the back of the board, the top of the board here in this picture, it would be ground, 5 volt, and then the servo pin. And then you configure that servo pin as a pull down. And what that does is it leaves the 4 pins up here at the top available. So what I would do is pull so normally you do 2 wires, the outside pins on an end stop. What I can do is combine. So say I'm doing left and right, left and right. I can leave the 2 lefts as direct runs, and those go to my pins, right? The PE6 and PE7 or PB6, PB7, whatever it is. And then I take the other 2, join them together into a common ground, and we should be good. So that would enable me to run 2 end stops out of that end stop pin, the 4-pin end stop, and we would be good. Um, So yeah, that should be good. That should enable me to run in stops and build the Filametrix, build it. So with that being said, let's get into a little bit of building here. And yeah, welcome on in, Papa. See, how are you doing today? We've got our array of parts here, and there's a few more parts than normal. You know, the front shroud, of course, is pretty standard. Um, our um, the actual tool head piece is a little bit different. You'll notice a couple of differences. One is in the top here. This is actually made to take a M3 hex nut, and we're supposed to drill out the threads of the M3 hex. And that's critical, and there will not be any PTFE tubes sticking out between here and the other part. And that's because of this piece right here. This piece um, becomes a pivot joint, and we'll have a piece that slides in there. Piece that slides in there. I just need to get my fingers aligned. And it's going to go in there like this. This is the filament cutter. So this becomes a pivot joint for our filament cutter. Okay. On our CW2, once again, it looks pretty similar. The main differences here, get this up, once again, are going to be the spots for our two end stops so that we can run a sensor before and after the actual um, extruder gear. And that will help with the happy hair and the Enraged Rabbit Carrot Feeder. Yeah, and then we'll have a couple of other pieces like these two pieces here. And these will join together. And I'm not 100% sure where it mounts, but this is going to be the arm that will trigger the filament cut, right? So there'll be a macro that we'll add some data into our filament change macro, I believe it is, or the filament change section of the slicer, one of the two, to tell it where to go to basically cut the filament at. That's kind of where we're at. Um, let's let's just start working through this a little bit. I have gone through and done all the heat set inserts. I did that last night while I was trying to get things set up and arranged up here. Um, I will post a picture later, but you see how I tend to work when we're building printers. Twice now at the end of the stream on the DO build, it has been like a total disaster. Like electronics just spewed all over the table with the DO build, but we're doing real good. We're almost done with the wiring on that, and it's coming along nicely. Once again, I got all of the heat set inserts done, and we're going to start right here with starting to put our guidler arm together. We still have the guidler arm and things like that. So it's a matter of lining the parts up with the gaps in the other side so that these two pieces come together. And I know a lot of people have asked, like, why are these being printed in two parts? It's really just for printability. That's all it is to ease the printability of these parts. Ease the printability of the parts, but then every once in a while you need to go in and just file a little bit if you're get like a little blob on the top of one of these small islands. It'll keep it from engaging properly. So all I do is go around and just do a slight file around the edge. That normally solves the problem just nicely. Now we need a M3 by 16 socket head cap screw. This is going to go through into the heat set insert that we put on the other side. That's just going to make these two parts one. Hey Maniac, good morning. How are you doing today? Looks like we got an ab break getting ready to start. Okay, so we got that done. Next up, we'll do our needle bearings, and that's the one thing I didn't do is grab my Mobilux so that we can grease our bearing. And I'm going to grease this without doing gloves. This is a pretty simple one to do. Palm gear, our spring, there we go. Needle bearings. So this is a full, we'll say BMG gear run ice kit. So we'll have extras is kind of where I'm getting at here is because it's made and designed to work with multiple different extruders. We'll have all the basics that we need, and then there will be some extras in here. Specifically, some of the gas. Keep those. You never know when you'll need those. And on your gears, remember that there's always one that has a spot for a grub screw. That's the one that goes on your geared shaft. The other one without a grub screw is your idler bearing side, which will then go with your needle bearings. We'll get our needle bearings in here. Once again, we'll use our finger just to keep those from falling through. We're going to put a little bit of Mobilux in here. And then we're going to take the shaft, make sure we get the shaft that's the right size so it's not too long. So we'll validate which one we've got here. That one would be too long, so we're going to take the shortest of the three shafts. That's the one that would fit in our idler bracket here. That's the shaft that we're going to use to push in here. So we've put a little bit of grease in here. We're going to take our shaft and push it in on those bearings. And we've talked about this before. As we put our finger at the bottom, it's going to keep that grease from squirting out the bottom. We're going to start pushing the shaft in. You'll see the needle bearings start to rise up out of the top. And that's where the grease is basically under pressure now and pushing that up. I'm just going to take my finger, push that needle bearing back down with the fingernail on one finger, and then push the rod in. And that's now going to squirt all of that EP2 grease into those bearings. and you'll see some of it popped out of the bottom. It is okay to get some of this lubrication at the thicker gear shafts down here. You do not want it in the small teeth because that's where your filament's going to be. So when you go to take and wipe that excess off, wipe it away from where your filament's going to be, right? And like I said, if you get a little bit in there, don't worry. That'll be perfectly fine with the gear meshing. Don't worry about that. So now that we have our gears on here, or Mobilux, push through our needle bearings here. We're going to take this, we're going to line it up with our guider bracket here. Big side on one side, smaller side on the other. Match that orientation, and we're just going to press that in. Then make sure that it twists and turns. So that's one side done. We'll take our Mobilux and cap it up and put it away. I put it away for now. I'm just going to set it off to the side. So how's it going, Pez Liz? Sorry, I haven't been catching streams the last couple of days. It's been an overwhelming week. A little bit of an overwhelming week, to say the least. Okay, next up, we're going to work with the same piece that we just did, but we're going to need our knurled nut and the spring out of the other package here. We're going to grab the knurled nut or thumb screw, the spring, and you should have a little plastic washer that goes on there. If you don't have the plastic washer, take a regular M3 washer and use that. We're going to take this. It's going to go through the top portion here that has the cutout in it. That's to allow your spring to line up there. And then we're going to grab our shuttle. Make sure it's properly oriented. Just tighten that down some. Don't swing for the fences on the tension here. Just get it going. It does give you a some information on the springs and stuff like that if you're not using the standard Bondtech gearing. I believe this looks close to the Bondtech. Yes, yes, it has been. So now what we want to do is we want to take our two bearings. I'm going to use this to start capturing some of these extra pieces here. We will not be using the these spring grommets or compression rings. And I don't think we're going to use these either, though we might use one later on. I don't think that I need 4 of the grub screws, and I'm not going to need these other 2 M3 pegs or the 2 square nuts for the build that we're doing. We're going to take those and just set them aside, and that just cleans up things and makes it easier. Now what we need to do is on our shaft is test our bearings, make sure our bearings go on the shaft without any issues. If they're too tight, we just need to go ahead and sand the ends of those bearings. But these are a pretty good fit, so that's good. With that checked, we'll take the motor plate side, and we're going to stick our first bearing right down in this gap. Should go in nicely, be a good press fit. Want it to be a tight press fit as well. And we need to make sure that it's fully seated down in there all the way around. It will sit proud of the printed part. Don't worry about that. We just want to make sure it's fully pressed in. So look from this side and make sure there's no gaps around. Okay. So that's in. Next thing we're going to do is take the other MR85 bearing and put on the other side. And this is a little bit of a booger because it does go way down in there. And I wind up trying to get this lined up and then using something else to try and push it down in there, or taking, one of my larger drivers and coming down across the whole side to get it pushed in there. The big thing here is you want to be careful that you're not pushing on like the inner or the outer race only. You want to push them both at the same time. So that's in there. Now we're going to put a M3x6 flathead cap screw in here. This is going to be our anti-squish thingamajigger. Let me double triple check this. This looked a little long. This is actually an M3x8. So give me 1 second to grab an M3x6. We got plenty of M3 countersunk screws here from working on our DO droid builds. So. I'll do with the And the way I normally do this is I just put it all the way in until it's flush with the printed part. And then we'll call that good. And we should probably put this in with thread locker. That did feel a little, I don't want to say loose, but yeah, you want to put thread locker on this. One of your cousins had carbon monoxide leak at work. Ooh. Wow, I'm sorry to hear that. Yeah, I kind of worry about things like that with my son. So not where he's working at now, where he works in the RV industry, so building uh you know mobile homes and trailers and stuff like not oh yeah, like 26-foot and smaller trailers. And in one of his previous companies that he worked at in that industry, he was doing all the fiberglassing. And they, in the time he worked there, I think they had like 4 or 5 buildings that burnt to the ground because yeah, RVs in Goshen, yeah. Um, they had like 4 or 5 buildings that burnt to the ground because the heat during the summer cooked off the epoxy. Sorry, I just heard an alarm start going off. Somebody's car alarms. Hopefully not one of mine. Though it could be. We're having high winds in the area. So now we're going to set our big gear. So big gear, tiny grub screw that we'll need to put some thread locker on as well. But yeah, I always used to worry about them either for the air quality or just the fire safety. But now he's in one where they don't do fiberglassing. It's all metal and wood stud frames. So a little bit better. Yeah, our big gear here. And we're going with the larger end going towards our main gear here. And we're just going to get it so that it's in that the D-ring section. We just want to get it lined up there. We'll do our final spot once we get it in the printer or in the tool head. Okay, so we'll align that fully later. We did put some thread locker on there. It does give us a measurement of 15.6. I just set it on there and then align it with the filament. It's easier. Hey, Zombie, good morning. How's it going? Oh, yeah, it is. It is extremely messy and dirty. That when you're trimming the the excess from the molding process, that stuff goes everywhere, and you're supposed to be wearing a respirator. And because it's like 100 degrees there in the summer, and they don't circulate the air because once again, the epoxy fumes and stuff can catch fire real easily. So yeah, it's just a big mess. So we're going to take and our shaft and mount or set it right on top of our bearing to go on there with no problem. You do want to make sure that when this goes on, one, the reason that bearing's proud is so, like you'll see there, there is a gap between the plastic bearing and the plastic housing. You want that. That's what we're going to be looking for. The other thing you want to look at is looking from the back and using your finger, just make sure that that shaft does not protrude past this plastic. If it does, stop. Pull this gear back out and sand that gear shaft down. Otherwise, it'll rub on the motor face and you'll have very bad extrusion issues. Okay, whoop. Take the other part, the front part, we're going to align that on the shaft and align it in the cutouts. Good pop together. And I just want to show you all this. No measuring, no looking. How does that look for alignment right there? I mean, I don't know about you, but that looks pretty darn aligned to the filament path. Maybe I built a few of these that I'm getting used to it and I can just eyeball the filament path. Oh yeah, yeah. Sawdust, any type of dust, whether it's sawdust or sanding or grinding metal, fiberglass, resin, all that is bad, and you got to take care of yourself. M3 by 25s, M3 by 20, 3 by 20, 16, 20, 30. Okay, so well, how about I grab the other package here that has various screws in it that came as part of the kit, and we'll have our LEDs along with a rainbow barf LED. That would probably be the M6 screws that we could have used. A couple of heat set inserts. We'll just toss those into the pile. Another set of LEDs. Which one? I bet those are M3 by 25s. These will probably be the long ones to put the shroud on. Not sure why we would have a magnet, but there's a magnet. Ooh, super long screw, and then some random wire. This would be to do our LEDs, because we will have to put our LEDs together for this. M3 by 50. Oh, I do. What do we use an M3 by 50 for? Oh yes, yes. I love. So I grew up in Florida. So the Strawberry Festival down in Florida was awesome every year. Yeah, these are our M3 by 25. So we use these. The one in the top left over here, and one in the bottom right. See where our screws will go. We'll screw these down. We're not going to really ugga-dugga these down. We're just trying to get them seated. And when you feel that change in tension, call it done. If you squish this, then you'll be undoing this a little bit later. This one's not going in, probably because I've got some plastic swarf in there. So we go from the opposite side, break that little plastic bit out from putting in the heat set insert. Redeeming quality of Plant City. Yep. I keep forgetting that you went down there a lot, Pezliz. Okay, so just like that. Now it tells us to put filament in there, verify the filament path, which, like I said, we are lined up. I just need to move the gear around so that I can tighten up the rub screw. Okay, so that's tight. We do have that clearance on the back side. Now we're going to take our shuttle that we built. This is going to go in from this side. We're just going to make sure it's fully pressed in there. We can see the shuttle coming through on this side with the gap for the latch. This is going to be another M3 by 25 socket head screw, and I'm going to have to grab those. This goes down here in the bottom. Just make sure that your hole's lined up. And once again, this is a pivot joint, so you don't want to fork it down, ugga-duggas. You're just going to take it in until the screw is fully seated. Then you're done. Back it off because once again, you want this to pivot and move. Okay. We're going to add our latch in. Great. So I printed out 2 of these. And you need to make sure which one you put in. So this is the standard latch. This is the other one that I printed. You'll notice there's a cutout here. That's super duper critical. Because I printed the version for the ECAS fitting, it kind of bumps out there. So we need to make sure that we use the right latch that will have a bump out that will enable it to actually latch on there and open up around that ECAS. Because if we use the standard one, it's not going to latch around it in there. Take this, we make sure that it lines up with our latching mechanism. Another M3 by 25 screw there, going through the latch. Free Shoe University, FSU, yeah. You went to law school, not circus school, yeah. So there's our latch in place, and it opens up freely. Latch is nice and tight. So far, we're doing good. Want to make sure that our anti-squish thingamajig's there and that we do have access to it. And it feels like our gears did line up and self-align. The filament path is still good. I know I haven't ran any filament down through there yet. We will. Now we would mount the motor. Might get interesting when we go to mount our sensors. So let's take a quick gander over at the Filametrix directions. Oh, strawberries grow great down in Florida. Yeah, I loved going to the strawberry festival out in Florida. Okay, so this is the Filametrix. This is what we're going to be working on today as we're doing this build. The front shroud is completely the same. There's nothing changed in the front shroud or any of the fans. The changes are in the CW2 and then once again in the actual toolhead. And that's to accommodate this cutting lever that'll have a scalpel blade that goes. So we are going to use an ECAS fitting at the top. You'll see that there is an M3 heat set insert that will go down here at the bottom. And we're supposed to drill that insert out to drill the threads out, which I got to do and haven't done yet. You also want to double check and make sure that your filament path is nice and good. So take like a 2mm drill bit and run through there just to make sure that your filament path is nice and clear from the printing process. We didn't do that either. We'll do that now just to make sure that we're nice and clear through the filament path, which we are. And I'm especially going to do that top to bottom because once again, the filament path here is going to go down through 2 ball bearings. So I want to make sure that that filament path is nice and clean and open so that it can go through and trigger the 2 end stops when we get there. There will be once again an M3 nut that goes into the top of the tool head base here, and that's going to have the threads drilled out as well. So that's something else we need to be cognizant of. I have the cutting arm with the knife holder that we'll put in here. Scalpel will be the blade. M2.5 by 16 socketed cap screw spring. I'm not sure if they provide a spring in the ERCF kit. If not, I do have the spring from a ballpoint pen here. Just a standard ballpoint pen spring should work from my understanding. So we'll have a spring here that we can use. Okay, Mod Light, go have fun hog hunting. I want to go hog hunting at some point. I just need to get a good. A lot more of our wild hog is on the East Coast of North Carolina. Need to get it up. Yes. So this is the Enraged Rabbit Filametrix that we're looking at here. There is a version for Clockwork 2. That's what we're building. And there is a version for the LGX Lite, but it doesn't allow for the sensors. Various tool heads. Need so one of the things that we will be doing is getting into the package of Enraged Rabbit Carrot Feeder parts. So we do have, I did grab that. I'm going to use the Triangle Labs kit for this one. We've got LEDs for the, I believe these are for the lane lights. We've got an LED strip that's used as well. Set of wires. This, I believe, is as a circuit board. Say it's the Binky or Blinky. That's the encoder board, I think. Grab some scissors. Yes, this is the ERCF Binky version 1.4. So this is the encoder sensor, I believe. This is what tells it that there's filament loaded at the ERCF side of things. Got a bunch of end stops because each lane uses an end stop. Bits and gubbins. Bits and gubbins are always my screws. There's the ball bearings, screws, heat set inserts, grub screws, bearings, some ECAS fittings, belts, needle bearings and drive gears. So I think what we'll need somewhere in one of these packages, there should be the blades. That's kind of what I was looking for. Comes at heat set insert. 2x10 self tappers. Three. Not there. Toss some stuff back in there because we won't need it right now. We'll probably need a couple of the ball bearings, so we'll leave the ball bearings out for now. Blades in here. Yeah, these look like the blades right there. So we'll need one of those. That's kind of what I was looking for, was the blades and the ball bearings, because we'll need those as we put this tool head together. So we're going to take our blade. Hey, Chewy, how's it going, my friend? Yeah, you'll see me jump around a little bit. We're going to do the end stops on here a little bit later because I need to try and just figure out how long the wires will be. And then once I know how long the wires will be, then I can go ahead and solder the wires, and then we'll just pop them in here and install them. And the nice thing is it talks about cutting the blade length down. Looks like these are already pre-cut. But it says to cut them down to 26 millimeters, and these look like they've already been pre-cut down to length. It doesn't have that little locking mechanism on the back. So we'll wipe that off just a slight bit. So we'll have our blade, and the blade goes into this piece. And watching Lee Marie do his, this is going to be a tight fit. And it's funny because it tells you to look through the hole and it should be lined up with that hole. Look how big that hole is. I don't know about you, but I'm not looking into that. So I think what I'm going to do is I'm going to set this printed part right next to it. And I'm just going to make a mark on my blade. That will tell me if I got it in far enough. And this is going to be a tight fit. Be careful. Don't slice yourself on a scalpel. And so the orientation when this prints is like this. So it's basically like an overhang in there. I probably should have printed it like this because it would have been easier with no chance of overhang. So I may have to reprint this part if I can't get it to open up some from that overhang. I mean, you do want it to capture that blade, but you also just need to make sure that you don't have a hell of a time to get this in to begin with. And you know, this is a blade edge, so it's not like you can sit here and try and push it down in there like that. And of course, it says to use a pair of pliers versus your fingers where you can slice yourself. And I would grab it like back here and just try and work it in slowly, little by little. It doesn't feel like it's getting in there at all. So yeah, I may have to reprint this part in a different orientation. The good news is I mean, it's a pretty simple, short or small part. So before I slice myself up, let me go ahead and reprint this. It'll be in the wrong color, but I don't think it's going to matter. Let me just start getting that ready to go. All right, folks, give me 1 second while I try and find this piece that I need. Yeah, like a 4-minute print. It's going to take longer to heat everything up than it is to do it. Well, and once again, this part was printed sitting in this orientation. So the entire width of the blade cavity is an overhang. Where if I print it like this, then it's just the slit that's the overhang, and that's going to print without any sag. And that's going to be the issue because looking in through the end is kind of hard to see. But that's where I'm getting it pinched, is right at the very beginning. And yeah, heating the blade up would probably make it go in a little bit easier and then be harder to get out as well. So I think I'm just going to print 1 or 2 of these. And in fact, I'll print 2 of them. That'll give me an extra one in case I uh, tear one up and install. But are you doing the bump cut or servo version? I've got the parts here for the, I assume this is the bump cut. And I'm not sure where this mounts, if it mounts on the Y rail or the X rail itself. I would assume the Y rail, but I haven't seen, unfortunately, there's like not a full CAD that kind of shows you where to mount it. And they don't talk about this other than just assembling the two parts together. So yeah, we got to get the blade in there and get that part on. Add the heat set tip here. For the heat set that goes above the cutter, suggest drilling the threads out with a 2.5mm bit. All right, so I will ask, did you guys put that in a pair of pliers and drill it out, or did you actually heat set it and then drill it out before you built this, if you did it? I'm curious on that piece there. With the same thing's going to happen with the bolt that goes in. I didn't do the heat sets. Darn it! I thought I had done them both. All right, let's pop the heat set up here and do a couple more heat sets real fast while we're waiting for the printer to print or to heat up. We'll try and set up a few more things here. Drilled prior to install. That's what I was thinking. I mean, it makes sense to do it that way. There's no chance of the drill grabbing and breaking the part, basically. It's adjusted a 2.5-inch drill, or 2.5 millimeter drill bit. So since we'll be doing heat sets, we can get that ready. Yeah, like I said, all we're going to be doing here is just drilling out the threads to make it a cleaner path for the filament to go through. And I'm not going to worry about the last heat set there. It would be used if you were doing the whatchamacallit, darn it. It would be used if you were doing the input shaper, but we're not. Input shaper will be done on the tool head here, so we don't need that. Let me try and drill this other heat set out real fast, and then that will give me the last heat set that I can set into the bottom of that. That was pretty quick and painless. We'll go ahead and get this set into the bottom here. And this definitely needs to be flush, so make sure that you flush it up with the edge of something, or use a flat surface to make sure it's nice and flat there. Because once again, that cutting blade is going to be coming right through this gap between here and the bottom. So we're going to need a M3 nut as well that we're going to have to drill the threads out on. So since we have the drill out, let's go ahead and get that prepped and drill the threads out of this as well. Okay, done with the heat sets. Well, Nomi, how's it going? Now run your reamer through. Yeah, I can do that. So the smallest reamer I have is a 3 millimeter reamer. So that would be actually bigger than. We can do that. That will make it. The 3 millimeter, after going through with the 2.5, it's not going to work very easily. I would have to drill it out with an M3, and it actually says to use a 2.5. So we got the heat sets put in here. This side with the little printed ridges, it's set down into the printed part fully. This is flush. Oh, okay. So the note here says for titanium backers, the backers should be centered between belt clamps, and the end of the presser mount should be flush with the end of the backer. So this would go on the Y rail. Because you wouldn't have the belt clamps on the X, they would be on the Y. And it looks like it goes all the way in the back left. So, oh, that's interesting, Royal Nomi. And quite honestly, I didn't see the first line. I just looked up and saw the drinking. So I was like, oh crap. It's early in the morning and Nomi's already drinking. Coffee, coffee. We got our maker cup. So we've been drinking some coffee. That's finished. So we'll go back and we'll just finish off the Dunkin' and then get into the rest. Yes. Coffee. So I need to get that print done. Let me. Yeah, I'll be fine. It's a tiny print. It doesn't need a fully heated heat soak chamber. It's in a happy hair setup. So it looks like that's pretty much it. It's the top and bottom of the tool head that's different. Now, I will tell you this. On the tool head portion, once again, coming out of the tool head, it's going to stop at the kind of where it opens up there to allow for the M3 nut. And basically what you're doing is you're putting metal at the top here so that that blade doesn't constantly cut into the plastic and wear things out, right? You want metal on both sides of that blade, and also it keeps it from doing this. Now, I'm going to set this up with a Dragon High Flow on stream. This will not be this is not the end for this build. There's going to be a different tool head used in this build. I just want to let you guys know that I am not going to use the Dragon High Flow for this build. It will be a different hot end that I use for this. And these are 2.5s. I'm going to have to dig in here some. If these ones will work. 2.5 or 2? 2.5. Yeah, once again, for the purposes of the live stream, I am putting in the Dragon, but the Dragon will not be the final tool head for this build. Because of that, I'm also not going to cut the PTFE for this because I can't guarantee it will be the same between this and the hot end that I am going to put into this build. I think, Zombie, you know which one I'm putting in here because we talked about it in the past. M3 by 16s. Here. M3 by 16s clamp the back, and then 2 more M2 by or M2.5 by 6, I believe it is what I have that will screw the top in and hold the top in. Well, I still need the other 2 heat sets in here. That will help to actually get the rest of the heat sets. It's going to be one of those build days. Hey, K2 Kevin, how's it going? Thinking about your 5th cup already? Yeah. Yeah, that's about where I'm at. Is I'm on, we'll call it cup 2. So the nice thing is the tool head I'm putting in here uses the dragon mount, so it's going to be a straight swap. And it's currently in the Trident, or my other Trident, so I know that it works and it's already plumbed for an SB 2209/2240. So I just need to basically pull it out of the plastic and do a swap out. I'm using a hot end that I cannot discuss on the channel. Um, it is a hot end that Zombie is aware of, and a couple of other people are aware of, that we are in a beta test with an NDA on. So yeah, so when my wife gets me Dunkin', it's, I'll say, full test. When I make my coffee, it's half regular, half decaf. I basically do a pot of regular, then a pot of decaf. And so the M3 nut that we drilled the threads out on will fit in right there at the top. Okay. And once again, your cutting tool is going to be mounted here. That's what that little cutout's for, is to allow this cutting tool to sit in there, slide side to side with the blade. So we're going to reprint this and see if we can't get it to mount easier. We'll have this as our dummy bottom end for now. We will go ahead and get our thing mounted and done in a second. Trying to think. Jump back over here and just see. We need to go ahead and install the motor. That is a M3x30. Pop this off and get it down so I don't burn myself on it, because I will. I know myself. M3x30, socket head cap screw. Motor, once again, know where your wires are coming from and how you want to route them. I'm going to have my wires coming from the top. We're going to just lightly set this in there and line up the one side with our front edge here so that we can run our screw through to it. And once again, this is a pivot joint for right now, so don't tighten this down fully. You want your motor to be able to pivot some. Okay. Now we're going to use an M3x8 with a washer. Fives. Will be the M3 washers. There we go. But yeah, I'm using a hot end that I'm under an NDA on, so that's why I can't really talk too much about it. But it goes well with this being a large size Trident. It'll definitely go well with that setup because it is a higher flow hot end. So I'm getting this lined up. I'm not tightening it down just yet because we need to set the backlash on the motor. And that's what we're talking about here is the gear meshing. Whoops, and I just realized that I didn't change the play over. Helps. So we're talking about the gear meshing. So you want to check the gear play. So manually move your gear and you want to feel a little bit of, we'll say, play between the gear meshing. And if there isn't, it's too tight, it's binding, then you want to rotate this back out some so that your gears can run. So feeling all kinds of tight in there. Like I said, you want to find that meshing where it feels good before you tighten it down. And then after you tighten it down, you still want to double check that meshing and make sure that it feels good and it's not binding or hard to move. Okay. That's there. Tightened everything up. Now we would do the whatchamacallit, the chain anchor. In this case, it's not a chain anchor. It's going to be an anchor for our umbilical for the board. So we'll go ahead and this takes a M3x20 from one direction. And I say this takes an M3x20. It's not because this is a different piece. So probably get away with an M3x8. Plenty enough. If we want, we can go to an M3x10. Go ahead and do that. We'll do an M3x10. Give us a little bit more purchase, but still won't go all the way through. M3x10 instead of an M3x20. Not going to tighten it down all the way yet until I get my next screw started. Make sure everything lines up. And that's an M3x8. Comes around from the front side. This edge right here. So you got to make sure you get everything lined up. Now you can tighten that side and then go back and tighten the other side. Okay. And our board's going to go right here. So our wiring is going to be cut fairly short and we'll repen it to go to this board. We need to latch. M3x16 is going to go through this hole right here. And that's going to be to mount our cover plate. So M3 by 16. Now this one goes into plastic, so you got to be careful that you don't whatchamacallit, screw it down too tight. Once again, it's a hinge, so don't ugga-dugga the heck out of it. You're just trying to get it lined up and threading into the plastic. And because you're threading into plastic, you don't want to, like I said, just ugga-dugga it down to the point where you strip the plastic out, because then you'll be reprinting your door. The door still works. The hole's going to line up here. So I've got a little bit of a gap here. So I've got to go ahead and back this screw out. And it's just a simple fact that there's a gap between the door and where the screw starts. So see if I can't take that out some. Once again, this is threading into the plastic of this piece as well as the door. So that's where I got my gap built in there a bit. Hey, Magcat, how's it going? Okay. Now I got that lined up and pressed in there. You can see my gap's going to be a lot tighter. Everything will line up down the side. It was just my fault. I should have had that pressed in before I screwed this all the way in. Oh, or works. Let me go ahead and latch this back down again. A little tight, so we'll unscrew this maybe an 1/8 to 1/4 turn. A lot better. Whoops. Sorry about that. Don't like it. Oh, it's catching on the screw. There we go. Now we still need to put our ECAS fitting in here. I don't know why I haven't done it yet, but we'll get that in there. We'll have to work on our wiring. We'll mount our board. There's going to be an M3 by 6 nut that goes, or nut, M3 by 6 screw that goes in there. That'll be a button head. And then we'll also need to mount our SB22 40 or SB2209, whichever we decide to use. Like I said, the board comes with an SB2240. I have not used that one. I don't know really the difference between the 2240 and the 2209 because I've always used the 2209. And I kind of have I think I've got some 2209s here. I may just swap their board out for my board and use the 2209 because that will simplify everything. I don't know if there will be a difference in configuration with the 2240 or not. So, but that's our top tool head done, except for the like I said, the SB22 whatever board, tool head board. We will add later. We've got this roughly put together. We'll need to add our filament cutter once we get those prints pulled off. Or shows a Revo. This might help to go ahead and add the other two screws in here. That way I have them. Well, I'll have them from the other tool head anyhow, but I'd already pulled this. Need to put them in. And then we'll get into putting together our front shroud, which there's no change to the front shroud on the Filametrix. Really, it's just, you know, your angle bar here with your tool cutter. It's changing your filament path. Once again, we'll put a little bit of PTFE tube in here. That'll be cut off right at the lower edge of our nut here. Adding this heat set, once again with the threads cleared out, drilled out, so that the filament will go smoothly through there. And then we're going to add 2 end stops once we get those kind of figured out as far as where we're going to actually plug them into and how we're going to wire them up. Oh, thanks, Urban Monkey. Yeah, I've had the pop blue and the pop pink for a while, and I planned it for a different build. And then I went with a different color scheme for that one. So I figured, well, hell, blue and pink and white will go together. So. Yeah. I'm getting impatient, so I went ahead and pulled this. So this one was printed horizontally. This one was printed vertically. Now look at those 2 gaps. So I think this is the better way to go. It'll be a little bit easier to get the part in there. And if I need to, I can still heat this blade up to get it in there, but hopefully we can get it in there without having to heat the blade up. Hopefully. Because once again, you can't push on this. Well, a little bit. So we'll just keep trying to go, and we got to be careful that we don't bend this and break it, that we keep it as straight as possible when we're doing this. If we need to, yes, I'll heat it up to slide it deeper in there. About halfway to what I need to do. Yeah, let's do that. Let's grab the hot air gun. Let's grab the hot air gun. It should allow us to heat up the blade and then push it in a little bit each time. So well, and I mean that happens. Halfway and you haven't cut yourself. Yep. Apparently it's not for lack of trying, because that worked out pretty well. At least we made some progress. I'm trying to keep the heat focused on the blade and not the plastic. We're getting close. I think that did it. Almost. And you really need to get this seated down in there, because if it's too long, it could potentially engage the wires. Well, that looks like it should be fine. It may not be as long, but that should be fine. It fully covers the path. And we're pretty darn, well, I mean, lining these up end to end, we're pretty darn close on the length to where it needs to be. Kind of hard for me to show it that way. Let me see if I can't line it up this way. So the blade on the top is lined up with the length of the blade on the bottom. It's to the hole. It's not halfway through the hole. But I'm not sure if that next millimeter is worth potentially melting the part or causing other problems. So I think we're going to keep it right there and call that good. So on that Filametrix part, insert the scalpel, which is cut to 26 millimeters, into the knife holder until you see it in the little hole. Use pliers to push it in to the knife holder. Some force should be needed as the scalpel should stay in place due to the press fit. If that's not the case, add some glue depending on scalpel tolerances. Put it in the knife holder. Put knife holder into cutting arm. The M2.5 by 15 screw is directly screwed into the plastic of the knife holder. Tip of the screw should be flush with the cutting arm or no more than 0.1 to 0.3 above it. So an M2 by a 2.5 by 15. I know I don't have one of those in my packet, so we're going to have to dig in here and see if it's in the ERCF kit. I didn't see anything that looked like it in this one. These are M2 by 10 self-tapping. Funny thing. This looks to be all the same size. This is a hodgepodge of different sizes. So guess what I get to do now? Want to see in your office? Yeah, I had my so the upstairs here was set to I'm going to try and take out all of the things that look like M3s real. My upstairs, I have the heater set to 68. So that makes life a little bit easier because when it gets colder at night, it'll just stay at 68, which makes coming up and streaming first thing in the morning a little bit better. But if I get like 2 or 3 printers going, I wind up having to put the AC on up here just because I'm the highest point in the house. So all the heat rises anyhow. And then with the printers going, it can just get a little bit unbearable. Not sure if there's a 2.5 in here. Whoop, whoop, whoop. There we go. That's the one right there. All we needed. The rest of these will go in here and we'll divvy them out in a little bit when we actually start the ERCF build. Once again, I'm only doing the toolhead for ERCF right now because I didn't want to build a Stealthburner and then come back and have to rebuild it with the filament cutout and the sensors and stuff. So it was easier for me to do that part now. I want to get the printer done. And by done, I mean, I want it to push plastic. And once it pushes plastic for the first time, which will be like a PLA print, then we can go ahead and before we do panels and all that, we will work on doing the ERCF build because I don't want to have panels and everything on it and have to work around that as we're possibly making other adjustments. So zero, that goes zero. Moved out this. Hey, Merrick, how's it going? Hope everybody's doing good. Kenneth saying, welcome on in. I guess I should probably do that. Take a look at who all I see in here now. I haven't said hi to everybody in a little bit. So let's take a look over here at Twitch. Users in here. Dual Design. AH Vitas. I'm not sure what that name is. Way. Bear Grills. Grills. Uh, yeah. Some of these names I just can't pronounce. So we'll just go with that. Welcome on in, everybody. For those of you that have been here before, you know the spiel. For those of you that are new, and I am seeing some new names in the, at least in the listening and chat, welcome on in to Digital Dragon 72. My name is Digital Dragon. This is the Dragon's Den. I am a 3D printing variety streamer here on Twitch. You may say, what is a 3D printing variety streamer? Well, I basically do everything from printer assemblies, like we've got a Mark IV down here. I used to have a Flying Bear Reborn 2 up here that we had assembled, which is a kit. We just put the kit, the main components together, boom, printer's up and running. We do printer modifications, do full up printer builds like you see here. I'm also obviously I 3D print some cosplay helmets up here, and I'm a prototyper. So this is a 0G Mercury 1 that was built under a closed beta. This is a full up frame build. So frame cut by Masumi, but I had to do all the blind joint holes myself and do all the frame assembly myself. Looking at CAD, there was no manual. I also did a trad rack under closed beta, and we're going to see that again because it's moved from closed beta into an open beta. And I'm going to reprint all the parts for it so that it matches our K3 color scheme, because it's going to get mounted to this side of the K3. And we will have the trad rack running on our K3, and then we will have the ERCF V2 running on our Trident that we're building, Trident 350, and I will have the parts to build another one. May go on one of the other Vorons you see here, whether it be the Trident 300 or one of the two Trident 300, or excuse me, 2.4 300s. We do have a Prusa Mark IV down here. I did order an MMU3 for that. I'm not expecting that to ship until late March, early April. So once we get that in, we'll do the MMU for that. We'll have a trad rack, the Prusa MMU, and an Enraged Rabbit Carrot Feeder with the cottontail and the full 9 yards. So we'll have 3 different types of MMUs here. We're going to have a black box build. I still haven't got shipment confirmation on that yet, but that will be coming. Once that gets here, I'll be one of the first people out of batch 1 that has them, and we will stream that build live. Let's see, what else? We're doing some 3D droid builds on the weekday streams right now. We're getting close to being done with DO. Done meaning functional robot moving around under its own remote control power. And then we will have a mini chopper build to go and a couple of ant weight 150 gram battle bots that we'll be doing on. Battle bots we want to take to Rocky Mountain with us. So that may be right after the Star Wars, the DO build. We'll do the 2 battle bots so Mrs. Dragon can start driving and practicing and tearing stuff up around the house before we get out there to Rocky Mountain. Yeah, that's kind of some background there. Um, we'll get back to the build. So once again, we've got our blade inserted now. We're going to mount that in this piece here um, with the with our blade in place. And let me see, it does show, it's hard to see, but in this image on the right, it shows that little, we'll call it the peephole, as being up on this longer edge from the pivot point. This is going to mount in here. Looks like I have a little bit of overhang swarf there, so we'll clean that up a bit real fast. Because we want this to be able to pivot and kind of ride up and down. So make sure that this area is cleaned out so that your part can move appropriately. Okay, so I was just cleaning out this edge right here where it had some overhang droopage. So this part, once again, careful of the blade, to go in there and be able to go up just a little bit. You want it to be able to rock up and down some because that will keep it as it moves around. So what we're going to do now is take our M2 by 16, we're going to feed it straight through into this plastic part. So your screw is free floating in the slot here. It is screwing into the plastic on this piece. That's why we need to set this in here. And we're coming in from this side and going into that plastic. Might be easier for me to start it out here. Get the first couple of threads cut in. That'll help. Now I'll back it out, put it back in the part, and we'll start. That way we're not trying to figure out, get a thread started while we're trying to screw it through another part. How you doing, Merrick? And so once again, you want this screw to come out the other side and it will still ride in the plastic channel of, I'll say, my blue part here. So this is basically becoming the pivot point, but it's a pivot that allows it to move up and down some as well so that it can do weird angles. Right, so just work it to make sure that it can still go. And you want this edge here to be flush or just slightly, and I mean ever so slightly, proud of the printed part, and you'll be good. Now, you'll see we have plenty of extra over here. This is an M2 by 16. They call for an M2 by 15. You can cut it down. You can sand it down if you want. I don't think this is going to get in the way of anything on the actual printed part. So I would say you should be able to leave it long, but we wouldn't be able to tell until we mount this. So what we need to do now is we're going to need to actually mount it back here on the pivot point. So needed. Doesn't tell us what screw to use to actually mount it to the printed part. And the other thing, when we go to, let me figure out what screw this would take. It is going to be a countersunk screw, which means it was probably in that bag of screws that I just threw back in here. So we go find that mixed bag of screws again. Uh, you'll see in the tool head assembly, not that. Um, yeah, so not or countersunk screws, and there's a long counter. So it's going to be the long countersunk. Let me look at the bottom up here again. There's one M3 by 18 socket head cap screw replaces the top left M325 hertz. M3 by 18 flat head cap screw. That's what I was thinking. So that's going to be this one. And that's going to be the one that mounts in here most likely to give us our pivot point. So what we've got is the lower tool head. We've got our cutting blade on here. Like I said, this mounting screw for that cutting blade's long on this side, but I don't want it protruding out the front because then it could foul on the printed parts on the front. We need a pivot screw here, which is going to be an M3 by 18 countersunk screw. And when we go to install it, in this cavity there and in that cavity underneath, that's where the spring goes. That's what's going to be the spring loading here. We're going to need that spring. And I didn't see a spring in the kit. There could very well be a spring in the kit. I am going to be using a spring out of a ballpoint pen. Right, I can get it to actually stay in there. Go in there, get that lined up. That piece lined up. M3 by 18. And yes, I know I will be having to take this back apart to swap out the tool head. Once again, I'm just not allowed to show you that tool head. Yeah, so that's how that mechanism's going to work. You'll have the spring in there. It's locked in at the pivot point. These two right here would be used for your whatchamacallit, input shaper. I'm not sure if there is a screw that's required to go here or not. As kind of a latch, or if that's just a cutout to allow it to work with the input shaping piece in there. But there's your piece, and this will be set up, and your bar is going to come across and hit it, do the cut. And of course, it'll stay down because of the other piece that'll be on top. But you'll have that little indent there that the screw is going to hit into, and it's just going to push it and do the cut. Okay, that's your tool head piece. This piece will of course mount on top. Good there. We're good there. Like I said, I'm not sure if there's a screw that goes down that bottom side just to keep that kind of like a latch. I don't think it needs to be. So we should be good there. Let me go ahead and put my screws back in here. All right, Urban Monkey, have a great day. It's a secret. Still seeing the, oh, I'm sorry. Now I know what you're talking about. Now I know what you're talking about. There we go. So I was looking at the bomb to try and see how long or how big the socket head caps or the flathead cap screw needed to be to go in there. And looking at the screws, there was a bunch of like M6 or M8, or I'm sorry, M3 by 6 or M3 by 8 countersunk flathead cap screws, and then one really long one. That was the easiest decision to say of, oh yeah, it's going to be the long one, which will be that screw for that pivot joint. Now we'll take the rest of these screws, kind of put them up. We will need a shorter screw for one of the mounting holes later on, but we will we'll do that when we get to it. It's I think it was, they said the left one going through the shroud. Now the top left is an M3 by 18 versus an M3 by 25 because it's only going into the front, not going all the way through. And get my extra blade put down in here. It's nice that they provided a couple of blades. Back up here as well. That's good. Okay, that part's done. Let me reset my mind. So we've got the bottom, we've got the top. It's going to mount to the tool head just like normal. So we're good there. This piece, the depressor. So we'll worry about the titanium backers and stuff here in a minute. Look for all backers with 1020, blah, blah. And it doesn't tell us squat about what screws to use there. So I'll have to come back up here to the bond to figure out what screws we use. So we need an M3 by 16 button head cap screw, an M3 nut, and an M3x8 flathead cap screw, 2 M3 socket heads to actually mount it to the rail, but it depends on whether you use titanium backers or not. And then 2 Voron heat sets. We've already got the heat sets installed in here. So let me grab the screw package again, because we're going to need, eventually common sense will tell me to stop putting this back in. So to keep the blade from cutting into the plastic, Teflon, no, but we got something else that's better. So on the toolhead side, there's going to be Teflon that goes from the throat of your toolhead up to the bottom of this M3 nut. We'll have a PTFE tube for guiding, and then we have an M3 nut on this side, and that's going to keep it from cutting or shaving the plastic at the top here. On the bottom side of our extruder, the CW2, we have a heat set insert that's flush mounted, and we've drilled the threads out of both sides of these. So it shouldn't cause us any problems with the filament. We drilled those out with M2.5 drill bit. So we should have a clear path of the filament. And once again, here we're going to have a metal ball inserted and then an end stop. And down here at the bottom, there's going to be a metal ball inserted and an end stop. This end stop is mounted kind of this direction. This one is mounted this way, kind of sitting flat. And this is going to provide us a filament sensor above and below the extruder gear. So this will allow Happy Hair, the Happy Hair firmware, to actually do a little bit of automatic, automatic troubleshooting, basically, by knowing where the filament has loaded to and where the issue is. Okay, so we need an M3x16 button head screw. Button head. There is not an M3x16 button head in this set. Got M3x16 like socket head, but not a button head. You need a button head, I believe, because that's what we're. Oops, wait a minute. My bad. Here we go. M3x16 button head. M3 nut. M3x8 flathead would be one of these. Got one of those. And we do have titanium backers, so we'll need M3x10 socket head cap screws. That we don't have. By the 6, but not the 10. No worries, we got 10. We got 10, and those are for mounting. Now we can put this back up again. Well, yes and no. So let me get this put up and I'll show you. on our tool head, we've got a cutout down there, and that's what this plastic piece rides in. Okay, the only reason that's popping up right now is the top piece isn't here to hold this in place. But this will have some pressure on the top, so it will stay in that direction, and then it just cuts. So this stays at that level. It cuts right across the top, comes back, and so it's going to give it a little bit of a possibly an angled cut when it does it, but it is going to give it a nice cut, and that should work fine. Now on this piece, we're going to come through from the back, and you've got your little cutout jogs in here. So that tells me that the side with the cutout jogs is going to go in there and line up with those. That's what's going to help it stay in place. I don't know the exact height yet. I don't think it really shows, but we can approximate based on how they show it. Maybe approximate. Essentially just start at the top anyhow. This is going to be the M3x8 countersunk screw will be used. And like I said, we'll just get this lined up in the slots. We'll tighten that. We'll have the ability to adjust that later on once we get the tool head fully installed. We're going to need the M3x16 and the M3 nut. This is basically going to give us the lock nut type so that we can get the right length from the back. And once we get the right length so that it'll trigger the our lever, then we'll just screw that down, lock it in place. Makes a good mechanism right there. And this screw is what's going to be hitting that depression there to do the cutting. That's done. So I think all the Filametrix stuff's ready to go except for the Happy Hair software. We'll worry about the PTFE once I'll do that off channel because once again, I am not going to leave the Dragon High Flow here. I've got a different hot end that I'm going to put in here that uses the same mounting as a Dragon. That's why I'm using this particular printed piece. Yeah. Yeah, you couldn't see the groove before. It's hard to see it, and it's hard to show when you're using certain colors on camera. Really hard when everything when I print completely black. When I do black parts, it makes it really hard to see things. Okay, we're gonna start working on our shroud. Standard stuff here. We need to cut out some um, supports. Some print in place supports need to be cut out. So let me put up my heat gun. By the way, I love this little heat gun. That was a really good buy. Was that heat gun? Okay, so we need to snip out some supports. These print in place supports on the sides that it shows in the blue. And you want to get these cut out as good as possible, as completely as possible, and then make sure that they're rounded over. Maybe even take a file in there. Because you're going to have wires that you're putting around in these grooves, you don't want to leave any sharp plastic edges that could potentially either cut the wire now while you're doing the install, or as the tool head's moving around, fatigue over time on the wires. Now these should be pretty static. They shouldn't move, but you never know. And I know I've had a tendency in the past to slice myself on plastic as well. So there's two down at the bottom, and then there's one right up here at the edge here. And this is just going to enable us to um, uh, clip our wires in underneath. All right. Miss Dragon just picked up a package at the front door, so she brought it up here. Not sure which one in that one. Um, like I said, I'm not sure which box this one is, so okay, so this is a 5-volt adapter that I purchased for a Raspberry Pi or similar thing. This is my order from DFH Trident. This is the basically like the plastic pusher. So it allows you to work out clogs in your tool head, as well as a nozzle tightening wrench. Surprised this got here this fast. And then some filament storage bags just to give them a shot. I've got open spools of filament everywhere. So I figure if I can dry them out and then seal them up, it would help versus just leaving them sit out and then having to, constantly try and get the moisture out of them. Long story short, this is one of the things that I ordered, but it wasn't what I really need to come in. What I really need to come in is the thing from DigiKey that's coming via FedEx, which will be the filtered inlet for the Trident build. So the kit comes with just a standard like fuse switched IEC socket. And on these larger builds and the boron builds, I really like the isolated input socket. Definitely more expensive, but hey, welcome on in, Daddy Wazzy. How's it going? Yes, guten Morgen. Guten Morgen. Um, okay. Um, so a little bit of the Dragon Den, right? So we have filament over here on the shelf. We have filament down on the floor. Oh wait, there's some more filament. There's normally filament down here that I am printing with. There's some filament back there in some containers, and then there's the closet, and that some rep racks on top of the standard closet. I've got filament everywhere, and it's just I don't have a good setup here to have filament all in one location yet. So, but I'm working on it. I'm working on it. My goal is to clear out these bookshelves so I can have filament all in these bookshelves, and then maybe more technical filaments here, and then all of my PLA in there, or vice versa. Um, I need to work through some of my filament, but it's not that I'm not printing things. I'm printing a lot of things. Okay, so we removed the support in this channel and the two down here on the sides. What's next? LEDs. So this particular build, I don't have a pre-made LED, so we do have to make our own LEDs. We are going to have to do some soldering here on some LED pads. Now this kit, I don't know why, it does have a set of 3 LEDs, and it's got a completely separate set of 3 LEDs and a rainbow barf. The rainbow barf has a different um, carrier piece for it. It uses, I believe, the same diffuser, but it's a different carrier piece for it. And I didn't print that out. I'll hold the rainbow barf out for a different build. That and eh, you know, these are RGB. So I need to have a, what is that, like an 8 or, yeah, an 8 LED for one of them. So I've got a rep rack down on the floor with filament in it. I've got a rep rack, or not a rep rack, but a rep box um, underneath the printers over here with filament in it that was tied into the MMU that was on the Mark III. It'll be tied into the Mark IV once I get the MMU for the Mark IV in and built. But the oh, whatchamacallit? There is a Ender XY on the floor in there, and there is a um, Recreator 3D pultrusion system in there that we need to get up here and work with one day. I've got, so I don't drink soda, so I don't get a lot of 2-liter bottles. What I do drink is water, so I've been buying the 1-liter Evian bottles. So I can use those to take those and cut them into the strips and then make my own pultrusion. They won't be as long as the 2-liter bottles, of course, because they're 1 liter. However, I did back the Slunaz FF1R, which is a filament joiner system. So I will be able to create my small rules or spools of filament and then make them into bigger spools of filament that I can then print with. So that is going to be my intent, is to try and start doing some recycling there. One of the other projects I want to do is Teaching Tech has a filament pelletizer, so that when you're left with short lengths, that you know you can either join them together and make a big rainbow thing and do it like that with the FF1, or if you've got short lengths of, I'll say, I don't want to like mix a bunch of different PLAs, but if you have leftovers of a bunch of PLA Pro and regular PLA and stuff, you can pelletize those and then use those to make other filament, or you can pelletize them out so that they're all the same size, and then you can melt them down into sheets because they'll melt better when they're all the same size. See, when you're taking a bunch of different prints and trying to melt them down together, they're all different um, sizes and shapes. So they're going to melt at different rates. Where if you can get the best consistency in the size of your pellets, then they'll melt a lot more consistency or consistently. So LED wiring. We've got some black FEP cable here, always great to have just a length of the same color, all black, which is good. We're going to take this and cut it down to size, and then we'll start doing um, our soldering. So it looks like I need 6 at 100 millimeters and then 3 at 120 millimeters. So let's start getting this lined up and cut down, and then we can start setting up for our soldering. So once again, we're going to need sticks at 100 millimeters. Yeah, we like racks in the 3D printing community. Um, I uh, I I do have rep racks in there. I need to put up some more. I've got the conduit. I just need to print some more of the parts, or maybe cut parts on my CNC. I don't know. I haven't decided yet. Um, but partly I need to determine if I'm going to put any type of shelving underneath that or continue to just put racks in there. We'll figure that out. But as we were talking earlier, we've got several projects. We do have a black box that we'll be printing or building this year. So that will be a 4 head tool changer for me. I didn't buy 5 heads yet. I only have 4. The 5th one I'm going to reserve for potentially a non-FDM tool head option. 4, 6. Now we need some 3 at 120. But something else that is coming to the channel will be a Milo mini mill. So we will be doing that somewhere down the road. That's batch 2. It will come with the VHD, so in a spindle. So it's going to be the longer lead time to get, but it will be coming. Okay, so 6 at 100, 3 at 120, and we are left with plenty of extra cabling, which we will be able to use elsewhere in this project or other projects as as it comes about. We'll toss this over here in the rest of our cable bin. Okay, so we've got our 3 LEDs. I'm just going to go ahead and pop these apart. I might pop you over to the other camera so I can bring you over here as I start to do the soldering. That. 3. I'm trying to think and plan out. Definitely need the OmniFixos. And you need to be cognizant of your inputs and your output when you're soldering. or when you're soldering the LEDs so that you're getting them in the right direction. Just be careful when you're clipping these and trying to hold them in place when you got to solder. Um, make sure you're very careful that you don't damage the LEDs. Do that. We'll bring this over here so we can hopefully get it on the soldering area. I'm going to need my solder crimpers. We'll go ahead and grab the crimpers while we're over here. And what I found when I was soldering, especially soldering the LEDs, using flux helped. Just made it easier when soldering. So if you've got some flux, might be a good idea to break it out and use it. Definitely need to get some projects done here because running out of room. Move things around. Kind of get myself a seat over here so I can be a little bit closer to. Yeah, I have a Shapeoko 3 XL, and I've cut the acrylic. I've cut some acrylic panels for my printers. I've done a lot of woodworking projects with it. Um, but the nice thing with the mini mill is it's definitely going to be more rigid and it'll be good for cutting aluminum. So I may be able to do some aluminum projects and especially some aluminum projects for printers and stuff down the road. So it'll open up some other things for me. Um, yeah, kind of looking forward to that a little bit. Now, a little goes a long way. You don't have to do a lot, but by adding a little bit of flux over the, whoops, adding a little bit of flux over, okay, hold on. Well, that's nice. Know why this is not working. So I guess we won't have a close up of the soldering. We'll just chat while I solder then. But having a little bit of flux on the pads really helps. You don't need a lot, just a little. So hopefully you have a syringe or um, like a paste that you can easily daub on. Just a little bit of flux right on the pads I found has helped me, especially when doing LA. We don't need to um, we don't need a lot at the end of the spec wire either. Just a very little, maybe millimeter and a half exposed. Spec wiring, so it's kind of a pain in the butt to um, well, it's a pain in the butt to get hold of because it's so slippery, which is why we use step. Um, especially in drag chains. Silicone's perfectly fine in umbilicals, but in drag chains, you want to use the FEP wiring. It will last a lot longer. But just trying to strip FEP wiring because it's Teflon coated is a pain in the butt. I also got a MIG welder not too long ago. Um, my neighbor was cleaning out. They had a family member that was that had died, and the remaining family member was being moved into an assisted living facility. So they were over cleaning things up, and they had like an oxyacetylene torch and a TIG welder, and then they had a it's a 110 MIG welder, so it's not a like I'll be out doing long welds and quarter-inch plate and all that stuff, but it is a decent enough welder that I can go out and do some things for projects around the house. So that'll be nice to have to play around with. Well, so we get our iron up to speed, a little bit of solder on it just to tin it. And this is where that flux will come into play. Up quick, knob a little bit, and that flux will make the um, solder flow beautifully right onto those pins. So there's no issue that solder flew or um, it flows just nicely onto that pin. That makes life a lot easier. Yeah, but it's more of I'm not going to be doing like, oh, let me do a foot long weld on quarter-inch plate. You know what I mean? It's really made for tack welding, and you're not. It's not a heavy duty, heavy use type of thing. What I was. All right, so this is coming into the inbound side. So this will be the part that I'm working on is the little swoop, and I will switch the view back over to the manual that I'm looking at. You guys can follow along. So I'm doing this swoop out here that will go to the um, SB22, or I'm sorry, to the toolhead board. Doing this initial in, and then when I'm done with the in, I'll do the out. And so it doesn't really matter which order, you just need to, whoop. It also helps if you tin your wires real quickly. So I'm just going to very lightly these wires. There's not very much shown. It's not going to take a lot of wires. Get the solder to work. Hit on the pad, heat things up. And there's a connection. Builds has like this perfect technique for doing this. I, on the other hand, do not. But like I said, using the flux, it it keeps the solder that you put on there right on the pad. It doesn't allow it to go off the pad. So that definitely helps in your wiring. Hey, Westry, how's it going? Thank you for the sub, sis, or the resub. Hope you're doing well today. So we got our 3 wires backed into place. Now we're just going to do another 3 wires, and we're going to come out in the same direction on these 3 pads up here. So makes it a little bit of a pain just because once again you don't want to clamp right on that LED. We're going to clamp right at the base where we just wire or soldered at so that we can get to the upper pad now to do the next set of wires. And I find it easy just to go from like out to in, out to in. So we start off with an in and then we'll just work our way down. And that way we know that we're going from an out to an in. So the first solder on every board will be to the in. And then the second solder on the board would be from the out. Make sure that, it helps me make sure that I keep my orientations. Yep, not much going on, Westry. How are you doing? You're trying to stay warm? You got snow. I'm sorry. It is 49 degrees here right now, but we got some wind. Like there was some scattered rain and snow potentially up in the mountains to the west of us, but I don't think they got snow. And right now we have had 0 snow this year in the say the Raleigh, Durham, Chapel Hill area. So that's been nice. Though I'm the type of person that if it's going to be cold, and by cold I mean if it's going to be cold, cold like freezing weather, I would much rather it be snowing as well. Once again, just a little bit of flux right on those pads. And then we'll come in with our soldering iron and some solder, heat up that pad, flux, blow out our solder. And it flows nicely. If you get a little bit too much, no worries. Come back, just hit it again with your soldering iron. You should be able to pick some of it up. A little dab to tin these. Too much in there. I actually bridged. Again, having that flux will allow you to do some cleanup like well. You'll notice as I'm doing this that you will when I show you, as I'm doing this, bringing the wires in the same direction going on the in other words, it'd be real easy to wires come in one way, wires go out the other way, but we're having to wire these so that the wires are actually going in the same direction so that it makes it easier to hold it down like that and slide it in. So just be cognizant of that. Make sure that you're tracing your wires and that you keep going 5 volt to 5 volt, ground to ground, signal to signal as you're or data to data as you're working your way through here, and you'll be fine. So the N, data N to be at the top of this. That's where I'm coming in. This is the first one that we just did up here. Up now do the bottom here. So we're going in, back out. So I need to make sure that I'm using the right 3 wires, using them in the right order when I go to use them. This over there so it's out of the way. A little bit of flux on my pads here. And make sure that my um, things in the same direction so that I've got my pins lined up. Do a little bit of solder to tin that end. Come in and tack it to the pad. Solder always melts faster with solder to edge of spool. Or in pin dwell. Solder was melting on the pad, but not getting into the wire. The wire itself wasn't. Grab the middle wire, bit, down, one to go. Oh, hey, Turbine 3D, welcome on in. Thank you for the follow. Rating with a party of 5. Thank you, thank you, thank you, Turbine. Happy Saturday. Oh, you're trying to figure out which bar exam? I would go for the lowest. Lowest bar sounds good. And that wire, and then we'll tack it to the LED. Okay, so those are tacked in there. Taking a good look. Yes, they are. And now we're going to turn this around because it's the same thing. We need to come off of these wires in the same direction. And I'm going to just double check that I did them in the same order, which I did. Now I'm going to come off these in that same direction. So I'm going to grab it from the bottom where I just soldered those wires on in the clamp, put a little bit of my flux on there so I can get these pads tinned up easy. Doesn't take a lot. Gonna go get some food? Okay, Turbine. Not a problem. Definitely understand the need to raid and run sometimes. Thank you for bringing your community with or over to us and sharing them with us. We appreciate that. Yeah. Tort is normally associated with, we'll say, civil suits, civil lawsuits versus criminal. Okay. So we're 10. Now we're going to need to clear off our strip the ends on our last 3 wires. And I get to do this again here soon because um, the LEDs are not working on Dragon, and I don't see anything wrong with the last two. So I think the one in the center logo, which is the first one in the chain, smoked. And so I got to desolder and replace at least that one LED to try and get the LEDs back running on Dragon. Which sucks, but that's life. That is life. Wire just a tad bit. And once again, we're going to come off of this going in the same direction. Realize that this one, before we get too far, let me do a repair. Yeah, normally I just buy the pre-soldered versions of these. But you get what you get. I've soldered a few of them. Too. And then once again, we're going to do this one last time for the last LED. We're only going to come into the input side. Get that lined up. We'll tin the pads and then tap those wires on and we'll be done. And this solder paste goes a long, long way unless you're soldering like bad or doing whatchamacallit, like solder masking and stuff like that. Uh, this solder goes a long, long way. Take your time. Also help actually solder the pads. Help somebody get through law school and you don't like tort law? Yeah. And also, my problem with tort law is it's kind of like the worst the worst of the worst, right? You get some people that are just, what do you call them, litigious, right? They're just going to litigate to litigate to litigate. But then you also have some people that are, well, I shouldn't say people, companies, and you have some people that just will fight, and they'll fight and win just because they've got the deep pockets, and they'll wear you down, right? So just that part of the law, I think, just brings out the worst in us as a society. Sometimes it's needed, but I just think it does. It brings out the worst part of our society. Okay, so I think we are good. Joints are good. They're all going same direction. Should be good. So we'll go ahead and shut off our iron. I'm going to set this over here off to the side because, once again, I know myself. There's a chance to burn myself. I will. I don't know how many of you are like that, but I know I am. I think we saw your new puppy on. I think you posted something on Twitter. If I remember right. If not, we did see in the Western One's Discord the other night. Hey, Mini Bice, welcome on in. Okay, so, and of course, this one end over here, we will put a We'll put DuPonts on when we go to actually install this, but for now, we start off with taking the first one in the string that we did, and we're going to put that in our LED holder. Slide that in there with all of our wires coming out through the top. Make sure it's fully seated in there. Then we'll have our piece and a user. Not that I have a bunch of these printed on the go. And there is a specific way that those go in. And if you need to, do not be afraid, once again, like I said before, of taking a file to these prints, because the better fit that you have on these, the better it will fit down in the actual Stealthburner toolhead. And especially if you printed these out of PETG like I did. My little diffuser pieces are PETG printed. I think it's a old crystal PETG that's printed in the clear print settings you can find on printables. So that part works. And this always tells us to start at the left side, and this is the one that's all the way at the end. So we're going to slide this in like so. Here we go. Make sure that it's, whoop, yeah, let's slide it in the right way. So we're going to slide it in with the light actually coming up, so it'll be exposed towards us, because that makes more sense, right? I'll have the light actually facing out, and visible. There we go. Make sure it doesn't rotate. Make sure it fully seats in there. And then I take the next one, which is that centered, and same thing. Kind of flip it around, push that down in the other side. And I tend to get my LEDs in first, and then I'll go and do wire routing. Because what I'm going to do now is just kind of push it around, push it down, see how it fits. Okay, that's about the center. Now let me get one side down. Over and start getting the other side down in that group. And then this excess, I just kind of push it in and push it down underneath this tab. I'm going to do the same thing over on this side. Just take it, squish it down, get it underneath that tab on the side there. So something along the line. And this piece comes up to the center. You need to put in your diffuser piece, and there's a specific way the diffuser piece goes in. You may notice on your diffuser piece, you've got this little rounded edge here. So that's the side that's still facing up and out. That diffuser will sit down in there like that. Make sure it gets fully seated down there. Go ahead and use something if you need to get it lined up and pushed in there. Or not. This is always the part that just is a pain for me. I don't know why it is a pain for me to get these in there. I don't know if it's just me or if everybody has a pain getting these in there. Like getting in on one side, but it's almost like there's something print-wise getting in the way of the other. Look like there's any print artifact. Huh? Okay, put it in the right direction and it clips down in there very well. So it looks like that little extra corner edge actually is the part that goes in. So I was wrong there. Now we're going to take our other our last LED, and it goes in and makes sure that the LED face is facing down towards the front. This has a clip on the side. Push it in, it will be a bit of a stress fit, and then that clip will hold it in place. Depending on your soldering job and how high it sticks up depends on whether or not this goes in very easy or a little difficult or what have you. And I have found once these get in, they don't come out. At least mine don't seem to want to come out very easily. So just be aware. I'm going to move these off to the side, and these I'm just going to route down in this channel. Once again, route down the side underneath the side retaining clip there. Channel, there's a little like S retaining clip edge. Sometimes find doing these wires one at a time actually helps to get it in and through. Then just kind of push it down into that little well there. These three are going to come up, and I probably should have put a connector on these before I did that. I've got to be careful so that I know that they're coming out in the right direction here. I need to get a connector on these before I go any further. These are inbound. So 5-volt negative. The center pin is the signal. And that's going to be critical when we get up here to our LED on the toolhead board. Need to know which pin which. RGB. So ground. Oops, sorry, let me grab the toolhead board. Be a little bit easier to be looking at the board when we're doing this. And let's go ahead, like I said, let's grab an SB2209 versus the 2240. I'm just used to using the 2209s, and I'm going to copy and paste the config from uh, my other Trident and just change the size. And that's going to give us the big start. So there's your extra wires that are pre-crimped. I think it has a thermistor wire that's already pre-crimped as well for those tiny JST whatevers. But what I want to do is grab the actual, say the fan or the front part of the toolhead board and actually lay it on here. So this board is going to sit, say roughly in that location. So my RGB is down here. So 5-volt is on the top. My 5-volt's going to go up there. And then my ground's at the bottom. It's just, it helps visually when I'm looking at it to make sure that I set the board up right. And that's why I'm doing that. So I've got another set of LEDs here that I'm looking at. So I say, okay, the input. So it's like this. That's the input. This way. So this would be the 5-volt signal and then ground. Yeah, because I had it on there and I wired the input first and then the output came over the top of it. So I orient this one in the right direction. So input's down at this end, so 5-volt signal ground. This will be my 5-volt pin. We're going to be crimping DuPonts on here. So we need to uh, take a little bit more off of the sheathing or strip a little bit more. Do these, and I'll grab my DuPont crimpers as well. And it should have DuPont connectors in here. I really like they add these because doing these incredibly any small connectors. Such a pain. In fact, they make these wires so you can actually just cut them to length and then solder them. Makes life so much easier. And then they've also provided a pre-crimped cartridge thermistor wire. So if you need one of those, you can have one there. Like I could literally, because the thermistor on this is the wrong kind, it has a wrong type of connector. I could literally just undo the screw, pull the thermistor out, put this thermistor in, and I'm good. That's the nice thing that packaging wise that it comes with. Well, that's cool, Hybrid Robotics. Yeah, I would love to have another dog, but just with my allergies the way they are, animals just are not in my future for like living in the house with us. I go and visit dogs though. I got my neighbor has a little cutie that we'll go visit, and then Evil Diesel has Link, and I'll go visit Link and his cats when I need some cheering up, which I did need over this week. We'll get our 3 pins out, and I always use my PA09s to crimp where the wire, the portion where the wire sits. And then I come back with the DuPont to do the part that goes around the insulation. Always works better for me. These are really thin wires. Be tight. There we go. One to crimp, four to go. And then once we get them crimped, we'll put them in the housing so that we know that it's pinned out in an appropriate manner. I should look at this before we start putting it in. We're still new. So as well, I have you here. How are you and Zombie doing with the birthday stream? Everybody get back to you finally? Okay, that's done. I need a housing. 3-pin. And I'll tell you, if you need any connectors, good gracious, there's enough connectors that I've literally done like 4 printers off of 1 bag of connectors from an SB2209. It's crazy number of connectors that we have. Okay, so this is once again going to sit up here. The signal's going to be in the middle. And the way I put these in there, I put them in there um, with the clips facing up. That way, when I put them in there, I can see if the pin has pushed this out of the housing. So putting it in this way, I know the signal, the middle to the middle. The right side of my thing is round. Round on my pin is to the left of the signal pin. That one goes there. Means my positive, or the one on the left, is going to go in on the other side. There we go. So this is now in the appropriate orientation to feed onto my board. Now I'm just going to snake these wires up through the channel, maybe. Up through the channel. And under the top little clip. Right and arguing the whole way. Wires can be like teeny. Never want to go where you want them to. Never want to. That part's in. I'm going to leave these connectors out for a little bit longer because I'm probably going to need them to do the fans. Fans have DSTs on them, so I will have to convert those over to DuPont. A couple of these big. Okay, what's up in Stealthburner? LEDs in. We got the wire routed. Okay, so the remaining support structure. That support structure is this little thin piece right underneath my finger, and then there's some on the side piece. They're made to just break away as we put in the fan. Okay, so those will break away as we mount our fan. We're going to take the 4010 fan they gave us. And we're going to make sure that it's going in the right direction, which normally means the where the sticker is the part that should be facing the thing that you're trying to cool. There could be arrows on there. In this case, there is not, but rotate the fan so the wires exit the top and the air is pushed inwards. So wires coming out the top. This is the top. And we're going to put the fan in that way. Let me double check. Let me think again. We'll be seeing our fan. So wires coming out of the top. There was a little bit of a gap down there, so we're going to make sure that our wires kind of traversing that gap. That we stick this in. So wire along the top, and then this gets pushed into that gap, then snap down in there. That leaves our wire to come around and follow this trough, just like our other wires do. Essentially. Got our wire coming through here, routed up through the little S stake, then up through, up and under that tab. We're going to leave this long for the time being. We will cut it to length once we're done doing our wire routing. Then we're going to need our 5015 fan. We're going to take the housing apart and cut a bunch of ears off. This will be a full ERCF hybrid robotics. Right now, what I'm doing is we built the Filametrix, which has the I know it's sticking up. Don't worry, we'll sit down here. This is the filament cutter, and then the toolhead also has a heat set insert at the bottom that we've drilled the threads out on, and it's going to have two sensors. So it's going to have a ball with a end stop at the top and another ball and an end stop at the bottom. So we'll be able to tell when the tool head is loaded, or excuse me, when the extruder head is loaded, and then when the tool head's being loaded on the other side. So both sides of the drive gears. So, and then we're going to do the filament cutter, which would be this portion. And it's all being tied into the SB2209. So, okay, sounds good, Hybrid Robotics. Sounds good. We'll continue this. Like I said, we're going to get the tool head on there, start doing electronics. And the next stream, we should probably be ready to start doing, finish off any basic electronics just to get the printer moving. We'll do a print to get, show that we got filament coming through. And then we will come through and do the Enraged Rabbit Carrot Feeder before we put panels and skirts and all that goodness on it. So all I'm doing right here is I'm just cutting off the tabs that hold the two halves together. You could just pry it apart, but I'm trying to cut the tabs so it's as smooth as possible. Save on my filing in a little bit. Just keep an eye on your wires so that you don't cut your wires. And cover that edge as you're cutting the plastic so it doesn't go flying and catch you in an eye or something. The tabs are all cut. The halves come apart. This is going to get thrown straight away. We don't need it. And then on this side, we need to cut the ears off. You know what? I wonder. Where's that part I just threw away? All right, this has ears on it, but I'm going to wonder if I set it there, like just set it back on there, if that's going to help me prevent from putting pressure on the bearings on this as I kind of trim this part away. I'm just going to come in here and cut these ears down as much as I can. Okay. And I really want to try and carve out as much of this as I can without breaking the housing, because anything that I can cut off wholesale here saves me from when I go to file. Because filing this gets to be kind of a pain. At some point, having a rotary tool will make it go faster, but you also have to be careful that you don't melt it in the process of trying to cut it open. Just definitely be cognizant of your fingers as you're cutting this stuff. You don't want to cut yourself, because one, it's going to hurt. Two, you're going to bleed. Now, granted, some people will say, "Is there really a printer build if you haven't bled on it?" And I can understand that. Just try and protect yourself as much as possible. Now that we've got the bulk of it, we need to go through and sand it down. And for that part, I find using and this is an actual name, a bastard file, or one of your files that's the roughest. Um, this is not my roughest file either. I've got a better one out there, but sometimes the ones that are really rough um, don't slide very easily, and it could run into other problems. Once again, protect your wires. Be careful not to keep pushing on that fan, because that's, you got your bearings in there. Be careful that you're not running off onto your blades. But you want to go through and file this down so it's as flat and round as the rest of the. And like I said, rotary tools can go faster, but faster always isn't better, because if it catches, you can drive a deep gouge in it, or you can total your fan. So I tend to always do these by hand, just so I don't damage um, the fan. I've got spares if I need to, but if you feel like your file's getting full, you can tap it out some. Or what I've also done is Take your wire brush, do this over the trash can or paper towel, and just brush it down. And that will clear your file pores so that you can start grabbing more material with each pass. And I've found that it doesn't have to be perfectly smooth. And honestly, I don't know if printing the um, cutting jigs for these help or not. I have never printed them. That's good enough. Now we got to come over and do the other ear, same thing. Clean my file face off. Like I said, depending on which fans you're using, this is a GD Stein. Winston fans, I think I've had a lot more that I've been able to cut off, which makes the filing go so much faster. Just take your time. Definitely a Dremel would make quicker work of this. Like I said, definitely the rougher the file, the quicker it'll go. Yeah, it just may have been that I wasn't talking to Trades. But welcome on in to Trades Minis. Printing 10 millimeter scale miniatures with 0.3 nozzle. Sweet. Yeah, it's pretty quiet on my side because I was, like I said, I was filing and just kind of focusing on filing so I don't come off and damage the fan or, like file my finger down. But I think we're pretty good there. Let me just brush off my file again. And we're going to take this. Throw that away. Now that we've got our ears cut off, this should go in pretty nicely. We're going to set this up. The fan goes towards the shroud and the opening goes on the side here. And we want to make sure that we push it up against this round edge as we put it in. And you should hear that piece of support that was underneath there crack as it falls in. And once it gets the better of the sanding job that you do, the easier this is going to pop in. I normally try and do it and go, oh, I got to sand it some more. But I filed that really good this time. And make sure that your wire is not fully kinked. There is a recess for relief there. Just make sure that your wire is not kinked, fully captured in there. And then there's your wires. Now we're going to use two M3x6 flathead screws to hold this in place. But hold off, don't do that. We're actually going to use some M3x6 button head screws because we're going to hold our toolboard in place. And yeah, it just comes with the ones to mount the main toolboard in here. So we'll need a couple of M3x6. I prefer button heads for this versus the regular ones because it keeps them out of the way. Meaning they're not in the way when you're doing any of your wiring. So you're going to set your board on here with your multi-pin connector on the left side as you're looking to it. And these are going to screw into plastic. So no need to really ugga-dugga them down. We're just going to line one up, get it started. Don't fully tighten it. Then we'll line the other one up. Then we'll tighten them both down at the same time. Now, one of the things you need to be aware of is all the little components right here on this left side. So you do have to be careful, and if your button head is going to touch things, mine are not, but if your button head was going to touch things, might be wise to then go with a socket head cap screw versus the button head. So once again, we'll take a look right there, and it's close, but it's not touching anything. So there we go, our board's in place. Now what we need to do is go through and do our fans. Now, I know because I've done them before, but we're going to go ahead and look at our SB 2240, 2209 look here. And it's going to tell us where things go. So we'll have RGB, 5-volt RGB. We have a CAN bus that's brought to the top. We have PWM fan and then two other fans. We have no designation of which fan goes where. As we do the install, once again, it says use M3x10 button head cap screws. I think 10's way overkill. I've never gone past 6, well, maybe 8, but 10's kind of overkill. What you're going to see here is we're going to do the first fan, which is our 5015 fan. That's going to loop up here and go to our top most set of pins. So all we need to do is figure out the polarity on the board. So negative is towards the top, positive is, I'll say, towards the bottom. So we literally just need to be able to loop this around and come back in the right orientation. So we'll say about there would be good. We'll cut that off. Now you know me, here's a perfectly good piece of red black wire that can be used for fan or in stop or something else. So we're going to keep this. Hell, this might work perfectly for, like the X in stop or something else like that. We'll hold on to these because it's a decent enough length. And I tend to do these fans one at a time just so I don't get them out of order or in the wrong. Make sure I do the pinouts right, the whole 9 yards. So strip off the ends a little bit here. We're going to need our DuPonts again. Grab some more of our DuPont connector. Am I very quiet, really, or is it just that I wasn't talking a little bit? I do apologize when I get started on wiring. I don't know. I tend to talk about what I'm going to do, but when I start doing the actual crimps or wiring, I tend to start getting quiet just because I'm focusing on trying to get good crimps. So I sit here and redo them. Okay, you think it was just during the sanding? Gotcha. Good. I got extra. Stripped a little bit too much. Let me start over. A little too aggressive. Stripping more wire. Much better. Wouldn't be a stream without a forked crimp, huh? Oh, sides down. Let's do the other side, and then you'll plug this in. Yeah, I gotta focus, especially when I'm doing the wiring. It's just, um, I'd like to say it gets easier, and to some degrees it is easier, but just because I know what I'm doing a little bit more, but still gotta focus. I'll say, as we get older, these wires do not get any better visually to see. And once again, we were negative up, positive down. So negative the right side, because once again, I want these connectors facing up so I can tell if they push out when I plug them in to the pin. Nothing sucks worse when you're sitting here trying to figure things out, only to find out that um the when you put the pin, or when you put the connector on the pins, that it actually pushed the connector out of the housing slightly, and that's what's causing your problem. So being able to look at it as you slide the pins on can tell you whether or not the you have a good connection there or not. That one's in. We're going to do this next one. This next one, you can swirl all the way around and come up, or you can come up on the inside. I normally try and come up kind of on the inside there and swirl right next to the CAN bus wires, rather than loop it, kind of loop it all the way around, come up. You can do it either way. But we're just trying to minimize these wires getting in the way when we go to put this on the tool head board. And also, like, try and stay away from going across pins or near, stand the chance of it raising. Because once again, this is a spinning fan. Got to be some type of a vibration up in this. Of course, this piece here is still going to need to get pushed around, plugged in as well. Let's actually get this piece. That may help dictate where we take this one as well. I prefer to run them around the side or behind each other. This, which means this is, I mean, it's doable if you just need to solder something up, or you could just depin it and maintain the housing, keep the housing and throw the rest away. it's up to you. I can tell you, I've got a bucket ton of these little JST connectors, so I probably don't need that one. Let's wire apart. And I tend to try and leave myself a little bit of wiggle room because that way, if I do need to, if you try and go like as tight as possible, cut it off there, and then you bork a crimp, you can't you can't extend the wire without doing a solder joint. Now you've got a solder joint up, and it's tight enough without having to add additional joints or movement around. So give yourself some slack so if you need to cut off and start over, you can. Other one, and once negative on the right, positive on the left. Then make sure that our wire is here appropriately. Just like that. And that way we'll get a nice good seal enclosure when we go and install this on the front of the printer. So I think all of the components are done there now. We just need to actually work our way through starting to install it on the physical printer. But, let me tune up these wiring pieces. Side so I can put up this stuff over here. Goes there. Give me 1 second because I'm going to bring the printer up here. I'm going to need room to actually bring the printer up here because it's a big printer. Once again, this is the 350 millimeter size, 350 by 350 by what, 270. So is going to be a bigger size than we normally do. We're normally doing the 300 size. Hey, Marcus, welcome on in. Welcome on in. The other thing we can do is get our ECAS fitting in there. They do provide us the ECAS fitting. And ECAS goes in here with the black piece in the bottom. So the ECAS itself should fit all the way down in. So you want to push that down. And then your blue piece will fit inside the ECAS and it's going to push down on the metal. So this is always the one that's a pain in the butt. And to get it started and then or lined up, and then you just have to push the heck out of it to get it to seat. There you go. Now we got our press fit. And you've got your locking clip. We'll use both of those later on when we do our assembly. And this gear we don't need. I don't even keep those anymore. Printer. Printer. We got a couple of things here on top of the printer. We had our board, the wires for the motors, some mounting pieces for said board, our Y-end stop, other components. Note that I still need to install the Y-end stop. And the underdeck wiring kit. But for now, we're going to focus on just getting things mounted up here. And we're going to focus on just doing some bed wiring and stuff too, and getting stuff brought down to the lower portion. So our tool head is going to mount up here on our CNC tap. Now we don't have our end stop, our X-end stop mounted yet, and we don't have the wiring done for our sensor because we probably are going to have to redo the wiring on this end of the sensor anyhow. We're going to cut these off and we're going to have to rewire it so that it's in the right plug. And I'm going to do that off screen because this is wiring those tiny connectors. I give myself 1 or 2 shots of crimping them. And if I'm having a problem, I'll just solder on the extensions that they provided and use their pre-crimped cables because it's just too much of a pain in the butt. So this is going to sit up here, and just like standard, it's M3x8 screws will be used to mount that. Just like normal. Not using that. Yeah. They have their Sorry, folks, I'm going to scroll here for a second. I just want to see if they call out the specific hardware. M3x10 socket head cap screws. Grab a couple of those because I don't think we had M3x10s in the Trident kit. There may have been some in the actual, again, and 3x10s through that hole over here. Now you're going through plastic pieces into metal. You can probably get away with some, whatchamacallit, some Loctite on these, but I normally don't. And I'm going with the premise that even though it'll be a pain in the butt, I will be able to get the two whatchamacallit installed, the two end stops installed here. It it might be a bad premise. I may have to come back and redo that. In all actuality, I'm thinking real fast. Um, no, I need to mount my board and figure out the the amount of room that I need for these because I have to drop ball bearings down into these slots. So trying to do a ball bearing and then put a thing on there, I'm gonna have to use gravity to help me out. And we'll work on wiring the bed and the motors down. Then we'll come back and work on this component, but the possibly work on it. Um, Bear with me as I think through what I want to do, because I need to put the board on to figure out the distance for my wiring. Sorry, I'm just going through some mental exercises right now. Um, let's let's what got the tool head, but I can't put the tool head 100% completely together because I need to swap out the actual like hot end to the hot end that I will use. Um, so that may still be mounted tomorrow unless we finish out and we can do the top, do that bottom off cream. Do that, I'm going to have to figure out yeah, let's go ahead and figure out that wiring. Then we'll come back and we'll start working. So confused on what. Yeah, let's get the bed, get the um the bed, the Z-axis cable chain in, get the bed wiring routed underneath. We'll bring our AB motors down, get those underneath, and then we'll come back and we'll do the soldering and stuff there. I want to make a little bit of progress on the wiring today, and I'm going to need to definitely um, do some more soldering because I need to solder up the X end stop and then the two end stops in the tool head. We can either do some soldering right now, or we can do this. And let's just do some of this. I want to see something else go on the main part of the printer, I guess. What did I do with the ends? So the cable chain ends. Tell me which one goes where. And yes, by the way, this is me. I jump around in the build, so I'm sorry about that. I don't think the filtered inlets come in yet, so do that piece. Put all of your hardware on. Got that ready to go on. Some of it is already on the bottom of the printer. Talks about doing the X and Y end stop. The X end stop is going to be mounted on the CNC tap and routed to the SB2209. Hey, Mark. So we've been working on doing the tool head for the Trident build. This is the Trident 350 build. So this is the biggest Trident printer that we've built to date, or any Voron printer that we've built to date. The only one larger than this is my Ender 5 Plus that was converted to a, sorry, hold on. Realize there's an ad break going. All right, you should be back now. So this is a Trident 350, Marcus. This is the biggest Voron that I've built to date. 350 by 350 by 270 in the Z. All of the Tridents are 270 in the Z because it's the same Z motors with the integrated lead screw. The only printer that I have that's bigger than these is the Ender 5 Plus, and that is a 370 by 370 by 420, but that's been converted to a 0G Mercury 1. So what color would you recommend? What kind of printer? What kind of printer do you have today? Like I said, I'm sorry. I am jumping around here. I'm trying to look at the diagram to figure out which end goes on which. So on the top of our Z chain, we want the end that I'll say has it's the any, which means the next link would go on the outside of it. This is the link we want at the top. We're going to use 3 M3 by 6 flathead cap screws. Grab those. Black Ender 3 V3. Okay. You want something that is not the same color. Okay, so you want to do something that's not black. Gotcha. It depends on how wild you want to get with your little accent pieces that you do. I've got a couple of different colors going in the background of my stream here. I really like the K3, which is a lime green with black. I think that really pops and stands out. See about switching screens here. So this is that lime green and black, of course. This particular one, I've done blue and black on the V0 over here. Um, this is a purple and pink with a black frame. We've got orange and blue with some black accents. We got red and black and copper. It kind of depends on what you're looking for. The nice thing is you don't have to stand or go with like I'll say a standard color scheme. I know there's people that's like, oh, blue and black don't go together. Don't ever put blue and black together. Why? It looks perfectly good. People wear blue jeans and black t-shirts all the time. Um, this is pop pink and pop blue, so it's sort of like a neon almost, or a fluorescent blue and pink. But I really like how this one's coming out, and this I think would have looked good with black or white frame. Okay, so if the innie's at the top, then the outie would be at the bottom. So once again, the outie just means that the link that joins it is going to go on the inside. That would be down here at the bottom. So we need some more of our 3x6 screws. But yeah, I really like the lime green of the K3. We did a black and blue for what's his name? Free Heathen. We did a black and or I'm sorry, not a black, red and blue frame or a red and blue printed part. Just gonna scoot this one over so I can get in there to install the chain mount, and then I'll move it back. Oh, you can't even see what I'm doing. Give me a second. Change the screen. Just move this lower mount over to the side to give me more room to get in it with my drivers here. Probably one of those things that would have been easier to install before we even mounted this to the frame. You know, we're trying to follow the manual to a degree, but I am going to jump around here. Um, it's it's kind of talking about, hey, install this now because now we're going to do some wiring. But I would have preferred to clean up the wiring down to the bottom deck and then start working on the wiring. That and it saves you from flipping the printer over constantly. Because as you add more and more stuff to this printer gets heavier and heavier and heavier. I hug Dragon. Oh yeah, that was when he hugged me for sending that printer over to him. Thanks, Darth Gollum. How's it going? Hope you're doing well, my friend. Hope you're doing well. Does it give me an idea of how many chain links? Let's see. Doesn't actually say. Aggravating, I tell you. So the next package that we get is actually parts for the droid build. Still don't have the filtered inlet for this piece. We'll get there. It'll get here eventually. So to grab my cable chain. And so this is the thing. If you ever get cable chains, you'll get two ends. You'll use those two ends, but you'll still have a huge amount of cable chain. It means just go and buy some more ends and reuse the cable chain you have rather than um, having to constantly buy cable chain. What I'm going to do here is just kind of look to see how many links we'll need. Go up a little bit more than where it's at, but not much. That should be good. Cut it right, or not cut it, but part right here. And once again, that's pretty close to having another full cable chain for something else. I've probably got enough cable chain for at least 3 more Tridents. Yes, the KB3D orange is very nice. And on your cable chains, always, well, not always, but if you can, get the ones that can open up because it makes it so much easier to be able to open it up, just lay your cables in there and then close it up. It's just so much easier when you're trying to manage your cables and do your cables rather than trying to have to, route cables one at a time through a cable chain. Alexa, play notification. Gee, thanks. But don't worry, we can definitely continue on the wiring and wire everything up but the 110. Normally what I would do would be wire up the 110 to the power supply. And if I'm using like a Meanwell LRS, it has a pot, so you can actually check the voltage and adjust the voltage somewhat. Sorry, I'm go like around and go. There we go. So in a situation like that where you can change the voltage with a potentiometer, you want to go through and validate um, that your 24 volt is actually 24 volt. and it's not inappropriately high or low because you can damage your components. So if it's like a Meanwell LRS or other third party, anything that's got a potentiometer, I like to plug in the 110 and validate the power is correct before I start plugging in anything downstream on the DC side. Um, it's just, I'll say, it saves some time and energy. Um, in the case of the UHPs, they are factory set. If it's a 24 volt, it would be 24.2. If it's a 48 volt, it's going to be 48.2. It's like zero point 0.2, I'll say high, for lack of a better term, on your power. If you're doing a LRS, you can adjust that, and I would adjust that to zero point 0.2 high rather than low, and then plug in all your downstream DC stuff. So we got that in. Now we're going to keep our wires, make sure we got a little bit of strain relief on our wires. There is a spot to put a zip tie and strain relief our wires right here. We want to do that to make sure that these wires in the Wagos aren't getting pulled every time this is going up and down. So let's grab a zip tie. These are, what zip ties? These feel like they're thinner than the normal zip ties that we use for Vorons. So let me grab a more normal, which is the 4-inch type of zip tie. I just think it'll go in the slot a little better. Spin it around, loop your wires up into it, make sure you got all of them. Close it up. And once again, just make sure that your wires aren't too taut. If they are, now's a good time to get yourself a little bit more slack on them. Then we'll zip tie this. Now, you can also put like another tie down point right here and give yourself another tie down point, which is something I might do. Just give myself another tie down point, but understand that this could flex, right? So you may not want to do that either. You may just want to zip tie your cables together to keep them um, as a single unit so they're not flexing around and possibly getting caught. That's what we'll do is I'll just stick another zip tie around here to keep all four of these cables nice and together. They're nicely zip tied up here. We'll have another zip tie point down here at the bottom. And that once again is to keep your cables constrained at both the top and the bottom so that they don't have extra bending capability and fatigue over time. Just realized I think I put this in backwards. That's not too bad. I can just pop this back off. Give this a twist. Oh, gotta go that way. The only way that bends. It might be easier before you clip that in there to get your other zip tie at least routed. Started. That way when you put this down in there, pull out the excess slack, you'll be good to go. There we go. Now we can pull this other zip tie tight, and that will lock in our wires top and bottom, so the wires here aren't going to be jostling around as much. Get these zip ties cut out of the way. Cut the zip tie, not the wires. You don't want to have a bad day and have to go back and redo all your wiring. Be kind to yourself and cut the wires flush at the head of the part. Otherwise, you're going to probably catch yourself and cut yourself. So I just got these wires from the bed running loose at the bottom. I'm going to set the printer on its side because we still need to mount our YN stuff. And that's going to go over here on our B motor. And it's going to be easier to either have this on its side or completely upside. Actually, we'll flip it all the way over upside down. Well, before we do that, let's run the A and B motor wires. So those will be under as well. What all we got here? We got A and B. Okay, and our printers, Core XY printers. Does anybody know what we say about our Core XY printers? Our Core XY printers go bah. So when you're looking at them face on, like this, right? They go bah like a sheep. That means back left motor is B, back right motor is A, or, you know, so that's what I've heard is they're bah, so B and A. So the B motor, go over on this side. We're going to push this through underneath. Try to push it. There we go. Then pull this around. Now, I will tell you that I do have a light strip, and I'm not sure which way I'm going to bring the lights down. I'll probably try and bring the lights down. I might bring the lights down this way, because the other side I know is going to have the other thing. So I'm probably going to have to cut these off down the road anyhow to add additional ones, but I'm going to go ahead just because these are a little bit, just say unwieldy. Not unwieldy, but the wires the way they are. We'll run them down through here. Try and keep them a little tight. Now, the other thing that you could do is, if you really wanted, you could use some cable sleeving to make this even nicer rather than having the bare wires there. You can run the wires down in the channel and use some, what do I do with it? Here we go. Use some of this to cover up your channels. which I plan on doing anyhow because you will get filament shards down in these channels here. So I tend to put this material down in these channels, and uh, it'll keep stuff from getting down in there. And it just press fits in, and you do have the ability to run wires underneath it, and that will give you one, a cleaner appearance, and then two, it will enable you to, like I said, keep from getting stuff all the way down in there all the time. And that way it makes it easier to keep your printer clean, or like if you're going to vacuum it, which you probably should do occasionally. So you can route the wires underneath this, and that way you won't even need these. You just jog it into the channel and then run this strip down it, and it will cover it up nicely. Yeah, do something just like that. And like I said, you can run your wires down through there. That will give you a clean appearance. And you can get this in multiple colors. So if you have like a blue frame, you can at least get a blue. It probably won't match it 100%, but it'll match it. It'll cover it up a little bit, and it'll blend in with your chosen color scheme. Once again, cut off the tails without cutting your wires. And this will be temporary. I will clean up the wiring a lot more later on as well. Um, but for now, whoops, turn this back around. See, this is a little bit harder to deal with as a 350 than a 300 because it's literally just as wide as my table is. Once again, we're going to route the A side now. Plug this in and cable tie it down. Or I won't cable. Whoa, won't necessarily cable tie it all the way, but I will get the cable tie started. Leave room that I can run some extra wires down it. This would be the extension for the E, which we don't need because we're going to be doing a CAN bus. Won't need that particular wire for now. Now what I'm going to do is I'm going to flip the whole printer over, which, like I said, is starting to get a little more awkward because it's heavier. We have the whole printer flipped over. We're going to turn this so that our right side, so that's the front, the back is facing me. So this is the Z end stop. So this would be the back right side or the A motor. This is where we want to put our Y end stop. And so our Y end stop is going to go right here. And this is why we, whoops, I need to be ready to change the screw sizes out for a little bit longer because our end stop is a little bit thicker. So the wires that were there will not suffice anymore. So I'll take these out. Screws that are here. Three by 8 or in 3 by 10. So chances are we're going to go to a 12. 12. And then the other side is going to be an M5. There's an M5 by 10. So we're probably going to need a 12 or probably a 12. This gets mounted with our end stop facing forward with the M3 towards the linear rail. Twelve is not going to fit, too short. Next size up I have is 16, so try the 16. That worked. We grab an M3 or an M5 by 16. Okay, so end stop is mounted finally. And this is just a 2-wire. So we're going to bring this round behind the motor. And then we're going to loop it down through here with the motor. Why we were leaving the thing open. Why we were leaving the zip ties open and undone. We don't want to pull it fully tight. We're just going to get it relatively tight. We do want a little bit of a loop on the wires here just to provide some strain relief. We don't want to just like yank on them, pull them down. We want a little bit of slack there. That, make them nice and neat. And once again, like I said, there's other options that we can do. We can snake them down in the channel and just use the that material to cover them up, which I think I'm going to do afterwards. I just want to figure out exactly how I'm routing everything because there are a couple of other, we'll say, nice to haves in the case or in the kit, like a disco stick that we can run in here. And I may even go with like just a disco stick along the back top because I only have one. For whatever reason, there's only one in the kit. So it would be along the back, or we can do it in the front. It is 6 1/2 dozen the other. Okay, now we've got um, our underdeck wiring a little bit more prepped and ready. Let me raise you guys up. So as we talked about in the past, we turn this around. So I'm looking at it myself directly. This is the front, this is the back of the printer. The power inlet is on this back corner here. Okay. Let me just this for so the power inlet's going to come right back here, and we've got our line, our neutral or load, neutral, and protective earth over on the side. So in effect, this becomes my 110 quadrant. Okay. Our UHP power supply here and our SKR or SSR, and then we'll have our wires coming up here, and somewhere along this line here, we'll have our MCU. Move this over, give it plenty of room. We've got plenty of room underneath here because we're building with a Manta board. And so the Manta board has a CB1 installed, right? So we've got our 5 drivers. So we have A, B, and then our 3 Z motors, right? We don't need a 6 for the extruder because it's going CAN bus, and we do have, where's our CAN? These two over here are our CAN bus. So we'll send 24 volt up and come out of our CAN connector and have CAN bus directly off here. So we don't need a UTC or any other board in order to talk to the MCU up at the toolhead. What else? We've got our Raspberry Pi or equivalent on here in the CB1 module. So we don't even need a different power supply to power the Raspberry Pi. So that's all taken care of. Now, what that means is on this board, we can go with an EXP1, EXP2 Mini 128/64 display, which is what this board comes with, or what this kit comes with. Or because we're going to be doing an Enraged Rabbit Carrot Feeder on here, Happy Hair has a clipper screen compatible utility that works, that gives you insight into the Enraged Rabbit Carrot Feeder. So we will be going from here, and we're going to use the SPI screen, and we're going to come out of there and go into a 3.5-inch TFT display. It's either that or we can put a 5-inch display on it, but it has to be HDMI. So in that case, we will be using, the HDMI connector. So trying to see how things fit in here. Because we have an option that we can either go, I'll say kind of like in this orientation or in a more traditional horizontal orientation. It really doesn't make a difference other than, wire routing. So here's all of our 24 volt power input. So putting it on this facing side will keep my 24 volt runs right there. But at the same time, my DSI's back here, my Ethernet's up here, and my Ethernet jack will be back here. So if we turn it around, then we've got to figure out how to get our power over to this side. We can do something like this, which will let us bring our DCI out this way. Once again, all of our motors then have to come up, around, and down. I mean, we've got options where I'm going with it. And by options, it can mount like this, and we get a DIN clip on each side. If we go like this, we're having one DIN clip here in the center, and that's the only DIN clip. So it will become a little less um, rigid, or yeah, the mount wise rigid. So I think first off, I need to just get this set up, and then we'll get this mounted onto the printer. Need to throw some heat set inserts into that. So let me get this ready for some heat set inserts. It's 3 o'clock, so we're probably going to be calling the stream here very shortly. So I can take Mrs. Dragon out to dinner. If she heard that, because she did, she'll be coming up here like, okay, when we leaving, where are we going? All right, Ramon, take it easy. Yes, this is a white frame. This is a white frame from DFH. So it's a powder coated frame. I'm not sure if he goes through DLL PDF or not. I would assume that he probably does. But I can't be 100% certain. I'm going to take a knee here just so I can make sure that these are getting set all the way down a little bit easier. So this is a white frame with Polymaker ASA Pop Pink as the primary color and Pop Blue as a secondary. I think these colors really work together well. Okay. Those put in there, we will mount our, I think I am going to run it parallel with the DIN rail, something like that. I'm going to go ahead and I need my M2x10s so that I can mount the DIN rails. So this is a DFH or DeepFriedHeroin kit. He's based in Texas. And this is not like an LDO kit. This is I'll say a kit of kits, right? So it's a frame kit, a rail kit. Um, it was a grouping of kits that he had put together for, I believe it was Christmas time when I got this, and it had several upgrades in the kits. So it's got the titanium backers. It's got the um, kinematic bed mounting system. So rather than using the printed kinematic bed mounts, we're using the metal kinematic bed mounts designed by Whopping Packard. We're using, the SB20. Well, we're going to be using an SB2209. The kit comes with an SB2240, but I have never used that board. I've always used the 2209. And I plan on just grabbing my config off of my other Trident, which is a 300, and just adjusting it initially for size, right? Everything else should work straight off. I'm probably going to have to change a couple of things just in the SB2209 pinout configs, but it should be a drop-in place config change basically, which is what I'm wanting to do. And then now, while I think the pinouts are exactly the same between them, um, I want to be safe than sorry when I do a config copy from one printer to another, right? Um, but this is the third kit I got from DFH. Um, Now you get a shipping label real fast. So it's like, hey, it's shipped. Yeah, it may take a day or two to actually get out of his location and to the shipper to get to, to start its way to you. But I haven't had any problems. Everything I've ordered has come in and has been correct. So I know that there are some people that have had different experiences. I can only talk to my experiences. Okay. So we've got our board mounted on here. So when we go to do the SPI display, we'll have to play around, probably take the board back off just to get to the SPI cable. I haven't ordered the display yet. Um, so this standard, well, I'll say standard. The small SD card slot next to your USB 2s on here, this is the Surface on Chip or your SOC card. That's the one that attaches to the CB1. The bigger TF card down here, the bigger SD card slot, is the one that would go to the main MCU. Just pointing that out. We shouldn't need it to do any of the flashing that we're going to do. I do still need to put the heat mod or the heat sink on the CB1. The CB1s will run hot. You do want to put a heat sink on them. I do not know why they do not come with the heat sink as part of the package, because every time I've tried to run it without it, it all kinds of errors because it's getting too hot. So do yourself a favor and always put a heat sink on your CB1 modules. Magic Phoenix, I have not purchased anything from them. I've never heard of them until you just mentioned them. So your CB1 heatsink comes with this little thermal pad. You'll get a little thermal pad. You're going to place this over the CPU and the memory. So CPU and memory. And this is not super sticky. I don't know if it gets super sticky over time. Take the other side off, the protective plastic. Getting underneath it, and then it's popping off out from underneath my fingernail. Get to it. There we go. Both the little pieces of plastic off, and then the your heat sink goes on only one way. There's a cutout here, and that cutout is for your wireless module. This will just sit down on top there. And then provided that you took the little plastic Captain Tape stuff off the top of the holes, it's just a matter now of screwing in the screws that came with the heat sink. And all the way through the heat sink, through the board, into the lugs that are in the mandible. The opposite corners to make sure that I've got it lined up right. Okay, we got that on there. What else? What else? What else can we do? D-motor wires we can toss on there, but I want to start doing some cable routing. So we do have our cable channel. That's the other thing we can probably put on. So once again, just one disco stick. Don't know why I only got one instead of two, but there's one. We do have cable channel that we can use. However, we need to use it to cut it up. I'll be going to run one directly full length here, and then do some cutouts to bring it, you know, up around the den rail as needed. That way we can run these down and through without having to do a lot of excess wire management. All right, Timur, have fun with lunch. And yeah, I'll have to join you in that regard soon because it's I'm getting hungry. I'm getting hungry. Um, yeah, I think that's where we're going to call it quits. Off stream, right? I will figure out where I want to place my cable troughs and get those cut and installed. And then when we come back next stream, we'll work on wiring some things up. I think this is a good stopping point for now. We're getting close to being done with the basic, with our basic setup. And then, like I said, once we get basic setup, we get it moving, we'll go ahead and work on getting the, just pushing plastic. We're just going to push some PLA, just push a little bit of PLA, call it good, and then we'll start building the Enraged Rabbit Carrot Feeder that we will mount onto this printer. Because we are going to do an Enraged Rabbit Carrot Feeder for this printer. I'm just going to get the basics put together. I'm not going to fully enclose the bottom until after I get the Enraged Rabbit Carrot Feeder because I don't know what wiring is going to be entailed in and how I'm going to route that. It will be CAN bus because we are installing a Big Tree Tech MMB board in it. So I do know it will be CAN bus, but yeah, that's kind of the progress we've made. I'm going to do a few things, like I said, off stream, but for now, I am going to go ahead and figure out who we can raid into, and then based on who we raid into, well, not based on, we'll raid into somebody, and then I'm going to kind of bounce out and go get some lunch myself. All right, Twitch being Twitch. So they've now changed the little raid out in your stream management dashboard. It used to just be a list. Now it's like you get to see almost like screen clips of people that are currently live, which is good because you don't have to sit there and kind of troll them to figure out, ooh, and it's scrollable too. Even better. Even better. Okay, so who do we got? We got um, Painting Mario and Maker Deck, Chris Perillo, Maker Deck, Ugly Moo, Patrick W3D, Jerry 3DHP, Free Heathen. I think we may have went into Free Heathen somewhat recently. We're in an ad break. That may put a crimp in things. So as soon as our ad break's over, we will talk about the raid. I think I know where I want to raid into. So another 30 seconds for the raid to finish. And I'm thinking we're going to raid into Jerry 3DHP. So as soon as our ad break is over, I will get that started. Okay, ad breaks over, folks. I'm going to go ahead and say we're going to raid into Jerry 3DHP and see the Jerry show. I'm going to go ahead and get that started. So please follow with me as we go over to Jerry's show. Thank you everybody for being here. I really appreciate everybody coming and watching the stream and hanging out with me as we continue this build. I know we fumbled around a little bit trying to get that new toolhead put together. Like I said, there's no real CAD or anything. You just have a couple of pictures and some text to try and figure out. Thanks for going on that journey with me. And thanks for going on this journey with me as we head over to Jerry 3DHP. And we will see you guys on Tuesday as we continue the droid build. And then we'll see you back next Saturday as we continue this build. Thanks, everybody, and have a good day.